Hi guys, Levi here from Bright Young Brains. Anyways, I mentioned Levi, yeah. So I see sometimes in the comments, yo. Anyways, so a special thank you to to Yefro Chido Chashe and for setting up the paper. I think you can guess what the N stands for. But anyways, let me not waste any of your time, right? So we're going to go through the full paper. This is actually the Northwest 2022 September prelim exam memo. So question one here says we need to solve for x, right? So solving for x is obviously always straightforward. So we don't need to overthink anything. But with a question like this one, we know that the first bracket, we're going to make it equal to 0. And the second bracket, we're also going to make it equal to 0. So the only reason we're making both brackets equal to 0 is because the only way a multiplication question will result in you getting a 0 is if either one of them is a 0. So that's why in a situation where you have something like this, but this number is not equal to 0, you cannot make each individual bracket equal to that value, because the assumption cannot be that one of these numbers would have to be that number if it's not a 0. So for example, if you let's say had here 3x minus 1 and you had let's say x plus 2, and they say this is equal to let's say 5, you cannot say each bracket is equal to 5 and then work it out like that. You cannot. The only way we're saying that each bracket could potentially be a 0 is because we know that one of these need to be a 0 for your whole expression here to be a 0. But in a situation where this is not a 0, you would want to take this to the left and then multiply out your brackets until you have another trinomial and then solve that trinomial. But anyways, moving on from here, right, we can already see that the 1 here can go to the other side, becomes a positive 1. Divide both sides by 3. You're going to have x is a third. For the other one, x is going to be equal to negative 2. Okay, nothing crazy here. The next question, if they're going to ask us to give our answer to 2 decimal places, it obviously means that you are going to need to use your quadratic formula for you to work out a question like this. So using the quadratic formula, we know that this is obviously something on your formula sheet, but I doubt you need your formula sheet for this formula, because I mean, like, you use it ever so often. Our b value is negative 7, because remember, this format will always tell you what your a, b, and your c value is, as long as it's in standard form. So we can already see here our b value is negative 7, yes, and then I'm already making dumb mistakes here. I feel like I'm distracted for some odd reason, but anyways, 4, our a value is a 5, and then our c value is like negative 11, and then our a value here is going to be a 5. Okay, let's put everything in the calculator and see what we end up with. So in the calculator, we are getting our first x value as 2.34. The other one is negative 0.94. So nothing crazy here. Obviously, we all know that question one is usually 3 marks. Anyway, so this inequality question, the one thing I always say is try and get an idea of what kind of a parabola this is. It's a smiling parabola. So you're going to draw a smiling parabola. And then you draw like an x-axis. So once you've drawn this x-axis, you want to remember this is literally asking you where are the y values bigger or equal to 0. So the y values are bigger or equal to 0. So they're equal to 0 here and here, and they are bigger than 0 there. You see? So the parts here where they are bigger than 0, it's from this specific x value going to positive infinity, because these specific x values here are the ones that are producing this part up there. And then these specific x values here are the ones that are producing this part up there. So since we know that, now we can answer our question properly. We need to find out what is this x value and what is this x value. Now to do that, we make our equation equal to 0. We somewhat say we have to get the critical values, but what we're actually getting is just the x-intercept. So fortunately, this we can factorize, I think. Can we? Yeah, factors of 15 that give it 2. It's 5 and 3. Now to get a plus 2, you have to say plus 5 minus 3. And solving for x here, right, we know that the x value we're going to have here, x is equal to negative 5, or x is going to be equal to -5, and this is like +3. And then this is how you're going to answer this question now. So it says here, where is this graph bigger or equal to 0? So we know it's bigger or equal to 0 starting from this x value going to the left, starting from this x value going to the right. So what we do know is the way you're going to answer this question, you're going to say your x values are smaller or equal to -5, or those same x values are bigger or equal to +3, like that. You see, so this is going to give you 4 marks. So after getting your 4 marks, you are going to move on to the next question. And the next question, let's move on to the next question and see what we have to do. So on the next question, let's see what the next question says. The next question is a 6-mark question, and we have to work it out simultaneously. So working it out simultaneously, let's see what we have to do here. So in this situation, right, it looks as though we can isolate x. So isolating x, we're gonna have 3 minus 2y, and then what? What now? 3 minus 2y. We can label this equation number 1, and then equation number 2 is this one. So obviously equation number 1, we're gonna throw it inside equation number 2, meaning wherever x is, we're gonna put 3 minus 2y. So we're gonna have here 3 minus 2y, the whole thing squared, and then here we're gonna put y squared, right? And then here we're gonna put 3 minus 2y, and then here plus y. So the idea is here you're gonna have 3 times 3, which is 9, and then you're gonna have -6 times, and then a -6y, and then another -6y, and then positive y, 4y squared. If you multiply out this bracket, remember you're gonna have 2 brackets that look like this. If you multiply them out, this is what you're gonna have. And then you're gonna have -y squared here. -2 plus 1, that's gonna give you a -y. And then we are going to put, let's see, 4 minus 1, that's like a 3, right? Well, let's take everything to one side. You're gonna have 3y squared, and then -12, you're gonna plus 1. So it's gonna be -11y. That's kind of weird. And then here 9 minus 3, that's gonna give you a +6 equals to 0. So obviously, yeah, the way this looks, yeah, it's not looking very pretty. The reason why I'm saying it's not looking very pretty is because you see there's an 11 there, and 11 is a prime number. So working with prime numbers is usually very weird. Yeah, it's usually very, very weird. So we might as well even just double check to see if we have not made any mistakes or or anything like that. So everything looks fine. So this, we may want to use our quadratic formula. Y is equal to plus minus b squared minus 4ac, the whole thing over 2a, right? So the b value, let's see what the b value is. The b value is -11. So this is going to be -11 plus or minus b squared minus 4. Our a value is like 3. C value is like 6. And then a value here is like 3. And then what? Okay. So from here, it's a matter of putting everything in the calculator. So let's see what happens if you put all this into the calculator. So you're going to put your fraction button, -11 plus, you're going to have your -11 squared minus 4ac, the whole thing over 2a. Yeah, okay, that's interesting. We're getting a y value of 3. Y is equal to 3. So this is a bit reassuring because, I mean, like, imagine getting like a weird number here. Sure, that would be very discouraging because it just usually is. So the other number is like 2 over 3. So those are nice normal numbers to be getting. So that kind of gives us more peace. So here we can see x is equal to 3 minus 2y, right? So here also x is equal to 3 minus 2 times y here. This is like a 6. So 3 minus 6 is minus 3. And the other one, it's like 4 over 3. So 3 minus 4 over 3. What's going to give us? 3 minus 4 over 3. Let's see what that gives us in the calculator. It gives us 5 over 3. So this is like 5 over 3. That's the way we like it. So let's move on to the next question. Okay, anyways. 1.3, what does 1.3 say? Okay, so 1.3 is a pretty interesting question because, okay, so this is how I would work out 1.3. You are going to be glad that you bumped into this ad because we are hosting an in-person math grade 12 workshop. So the idea is there's going to be 2 workshops, one in Bryanston and one in Pretoria North. The one in Bryanston is going to take place on the 18th of October until the 19th of October. The one in Pretoria North is going to take place on the 20th of October until the 21st of October. If you want to follow the proceedings online via Zoom, that will only cost you $3.99. The full details for that are linked in the description below. The main idea with the workshop is you will be able to ask very detailed questions with regarding anything metric related, actually. Applying for university, upgrading, taking a gap year, math questions, very specific, very detailed math questions. And the good news is, as long as you sign up for the workshop, you will also have access to the full online courses, meaning prior to the workshop, you will be able to go through the online courses so that on the day of the workshop, you are able to ask very detailed questions. So if you do opt to join in online, that will be from the 18th to the 19th, meaning you will be following along the proceedings that will be taking place at the Bryanston branch. The good news is, if you do sign up for the Pretoria in-person workshop on the 18th and the 19th of October, you will also be able to follow the Bryanston proceedings online via Zoom, meaning you'll be able to ask questions, I'll be able to see them directly, we'll be able to chat, we'll be able to gel. It is one of those things you definitely do not want to miss. Seats are super limited, so you can hop onto our website and check if there's still space available. The one thing you want to realize about 1.3 is that, for example, at the top, you have a quadratic equation. At the bottom, you have an exponential graph. As I move away from the camera. So, with the exponential graph, well, at the top, we have a parabola, right? You can actually look at it as negative x squared plus 3x. This is the kind of parabola you have. It's going to be a negative parabola. This negative parabola, one or the other, if you take out x as a common factor, right, you're going to have negative x squared plus 3 equal to 0, which is going to be x is equal to 0, or or negative x plus 3 is equal to 0. So this is going to be x is equal to 3 because the x is going to go over. So meaning this here is a 0, this here is a 3. Okay, this graph down here is an exponential graph. It's an exponential graph that has an asymptote of -4. You see? And then it looks like a normal exponential graph. So somewhere here is going to be -3. Your graph is going to go like that. That's the way we like it. Okay, so they're asking here, right? Given f of x is equal to this expression, determine the values of x for which this is equal to 0. So for this to be equal to 0, remember you have a numerator and a denominator. So for this to be equal to 0, the numerator has to be bigger than, for this to be equal to 0, the numerator has to be equal to 0. So let's see, where is negative x squared plus 3x equal to 0? It's equal to 0 where x is equal to, we worked it out here, where x is equal to 3, or where x is equal to 0, you see. That's where the numerator is equal to 0. For 3.2, for 1.3.2, right, it says here, where is f of x undefined? So f of x is going to be undefined where the denominator is equal to 0. So we're looking for where the denominator is equal to 0. because as long as we get where the denominator is equal to 0, we will be working out where our expression is undefined. So let's work out where our expression is undefined. So working out where our expression is undefined, let's work with the numerator, right? So we're gonna work with the numerator. Where is the numerator equal to 0? So fortunately, us working out where 2 to the power of x minus 4 is equal to 0, it's not a big deal because this can go over to the other side. That's a 4, 2 to the power of x. Now, fortunately, these can have a base that's the same, which is a 2. Now, if you drop the bases, you're going to see here x is equal to 2. If x is a 2, the numerator will be equal to 0. And if the numerator is equal to 0, the whole expression will be undefined. Okay, the next one. They're asking us where is f of x below 0. So that's this is an interesting one because for your expression to be smaller than 0, right? As in for this number to be a negative value, the top needs to be a plus while the bottom is a negative, or the top needs to be a minus while the bottom is a plus. So the thing is, you can actually try and visualize these two on the same set of x's. So if you visualize these two graphs on the same set of x's, right, this is what you're going to see. You're going to see something like this. You see, it's gonna be, yeah, it's gonna look something like this. Let me actually try and make it better. So something like that. Yeah. Why am I being all fancy now? There. So what's gonna happen is, you see, you want a situation. Let me actually copy this thing. Let me take the whole thing, copy this thing, and then paste it down here. Okay, so the big idea is you want a situation where, remember, we're comparing y values here. Literally, we're comparing y values, meaning we need instances where the y values here are negative while the y values there are positive, and then vice versa. So if you compare, if you look at our two graphs, right, let's draw this. This is gonna go all the way to negative infinity. This is gonna go all the way to negative infinity. So we want a situation where the one has positive y values while the other one is negative, and then we want a situation where the one has positive y values while the other one has negative. So in a situation like that, it doesn't seem like it's going to be too difficult to find, you see, because if you look nicely, this here, let's see, what's the blunt one? You see, if you look here, this has negative y values, right, going all the way to infinity. This is at positive 3. So meaning where this x value is also a 3, you can see that this has positive y values. See, positive y values, and then this is having negative y values. So where x is bigger or equal to what? Where x is bigger or equal to 3. Those are x values that qualify for what we need to do. Because where x is a 3, right? This is, the parabola is having a y value of 0. So that's fine. And where x is a 3, this is having a positive y value, and then going onwards, this will be having negative y values while this is having positive y values. So that qualifies for this expression. The other portion that qualifies, we may actually, if you look nicely, right, this portion here all the way until 0 also qualifies, because this is having negative y values while this is having positive y values, you see. So that's a portion of our sketch that qualifies, because anything below that, yeah, it doesn't exactly qualify, because this is having negative y values while the other one is also having negative y values. So this portion here qualifies, you see. We need to know what this x value is specifically, like this x value here. We need to know what it is. So to get that x value, I think we did get it actually, because we need to work out where the y value is 0. The x value here is a 2. So we know that this is a 2. So we know that the other portion that qualifies, it is from where x is bigger than 0, where x is bigger than 0, or where x is smaller or equal to no, bigger or equal to 0, but then x is smaller than 2. The reason why I'm saying smaller than 2 and not like smaller or equal to 2 is because specifically at 2, our graph down here will be a 0, and we don't want that. So we should not include the 2, because specifically at 2, this y value here is a 0. So we're only going to say from 0 to positive 2. That's the only portion that qualifies for what it is that they have asked us. So this is a 3-mark question. Yeah, it seems like an okay 3-mark question, really. Nothing. Okay, this is actually not necessarily like a simple question. I think this is one of the ones that are actually kind of, kind of difficult-ish. Kind of difficult-ish. Okay, not necessarily very difficult, but I think the more you're gonna go through questions like this, I mean, you'll notice that these questions are not exactly crazy or anything like that. Anyways, let's move on to question number 2. Question number 2. It says the sum of a series is given by the following formula. 2.1.1 says calculate the sum of the first 10 terms. Well, that's easy because we just have to make n 10. If you make n a 10, this is what you're gonna have. You're gonna have the 10 squared, which is 100. So 100 times 3 is 300. And then this is 20. 300 plus 20 is like 320. That's the sum of the first 10 terms. Okay, nothing crazy there. Let's move on. Moving on, for 4 marks, it says we should calculate the first 3 terms of the series. So funny enough, there's a formula that says a specific term in a sequence. You can say the sum of the number of terms minus the sum of the previous ones. What I mean is, you are going to be glad that you bumped into this ad, because we are hosting an in-person math grade 12 workshop. So the idea is there's going to be 2 workshops, one in Bryanston and one in Pretoria North. The one in Bryanston is going to take place on the 18th of October until the 19th of October. The one in Pretoria North is going to take place on the 20th of October until the 21st of October. If you want to follow the proceedings online via Zoom, that will only cost you $3.99. The full details for that are linked in the description below. The main idea with the workshop is you will be able to ask very detailed questions with regarding anything metric related, actually. Applying for university, upgrading, taking a gap year, math questions, very specific, very detailed math questions. And the good news is, as long as you sign up for the workshop, you will also have access to the full online courses, meaning prior to the workshop, you will be able to go through the online courses so that on the day of the workshop, you are able to ask very detailed questions. So if you do opt to join in online, that will be from the 18th to the 19th, meaning you will be following along the proceedings that will be taking place at the Bryanston branch. The good news is, if you do sign up for the Pretoria in-person workshop on the 18th and the 19th of October, you will also be able to follow the Bryanston proceedings online via Zoom, meaning you'll be able to ask questions, I'll be able to see them directly, we'll be able to chat, we'll be able to gel. It is one of those things you definitely do not want to miss. Seats are super limited, so you can hop onto our website and check if there's still space available. If you have term number 1, term number 2, term number 3, if you want to know what term number 1 is, if you want to know what term number 3 is, right, and you only have the SN formula, you can say term number 3 is equal to the sum of everything here, right, minus the sum of the first 2. That's how you get T3, because if you take everything, right, and you remove the first 2, whatever is left is whatever T3 is. So that's the idea behind what we're doing here. So if you want the first calculate the first 3 terms in the series. So what we can do is T1, you can just say it's gonna be S1 minus this one is gonna be kind of tricky, but let's I think S1 is gonna be difficult to get. Let's do T3 first. T3 is gonna be S3 minus S2, of which S3 we worked it out to be 320. And then S2 would be we have to use brackets here. 3 with a 2 here squared, and then plus 2n, right? So it's going to be plus 2n. Plus 2n. And then, what do we have now? This is going to be like 320, right? 320. I need to put this in the calculator. Why am I actually wasting time? Let me just put it all in the calculator and see what it gives me. 320 minus this whole thing in brackets. It's like 3 times 2 squared plus 4, right? This is like 304. 304. That's term number 3. Term number 2, you do the same thing. You're going to say this thing here. You're going to say term number 2, right? Minus term number 1. So in the SN formula, you can see here, I'm just putting a 1. And then this, I put a 2. We're using the same formula, you see. To get S2, you have to put 2 there and 2 there minus S1. You see. Now, the answer here in the calculator, let's see what we're getting. 3 squared here plus 2 with a 2. The whole thing here, we're going to get negative 3 with the 1 squared plus 2 there. Huh? 11. Wow, that escalated quickly. Did it really? Wow, why do all these answers seem so wrong all of a sudden? Sum of the first 10 terms. Okay. Oh, what am I doing? This is the sum of the first 10 terms, not the sum of the first 3 terms. Nah. Well, I need to put something different there actually. Now I see why that answer looked a bit weird. So this is actually 11. And this one is actually going to be, yeah, let's fix this one actually because, what is the sum of the first 3 terms? Yona. 3 times 3, the whole thing squared. And then plus 2 times the 2 there. Everything. And minus, let's see. Huh? S3 is like what? 33. So 33 here minus this whole thing here. That's what it gives us. 3 with a 2 there squared plus 2 with a 2 there. That's like 17. So 33. The final answer here is 17. And then obviously T1, you can just say S1. So S1 is just 3 times 1. Because the sum of the first one term, the sum of the first, I mean, you get the idea. Just saying it feels a bit weird. But if you add up one term, it's just going to give you the first term. That's a 5. So this sequence, it looks as follows. 5, 11, and 17. The jump seems to be 6. Yeah. So it's an arithmetic sequence, which is fine. The next question says, it is given, is the given series arithmetic or geometric? Well, clearly we can say arithmetic because it is a common difference. You can even say that actually because it has a common difference. There you go. It has a common difference. So the next one, what does the next one say though? The next one says the following. If the last term is 161, calculate the number of terms in the series. So we need to calculate the number of terms in the series. Okay, it's a 3-mark question, so we don't need to overthink it. Well, we have the sequence now, so we can always just work out the general term and all that. So the general term, we know Tn is going to be equal to A plus n minus 1d. Now the thing is, the first term is a 5. Wait, the last term is this, calculate the number of terms in the series. So we can just work out, if the last term is 161, right? The first term is 5. N is going to be the position of 161. D is the common difference, which is a 6. So we can just work out n here. So working out n here, we're going to have 6 times n, which is like 6n, 6 times negative 1 is like that. And then 5 minus 6 is like minus 1, 161. And then the 1 goes to the other side, you would plus, so it's like 6, 162. If you divide everything by 6, right, you're going to have what? N is going to be 162 divided by 6. 162 divided by 6 is going to be 27. 27, there's n over there. Whew, what a wow, man. What a big wow. Yeah, everything looks so good. The next one says, in a convergent geometric series, the sum to infinity is 18 and the sum of the first 4 terms is this. Calculate the value of the constant ratio. Yeah, you can work this out simultaneously because I mean, like the sum to infinity is equal to 18. So what that means is 18 is equal to a over 1 minus r. Because remember the sum to infinity formula, which is on your formula sheet, looks like this. And then since you're dealing with the convergent geometric series, it means that since they gave you the sum of the first 4 terms, what you know is Sn is equal to, since it's convergent, you may want to use this version of your formula, 1 minus r to the power of n, and then 1 minus r. Now, S4, so what that means is the sum of the first 4 terms is this. So what you can do is, this is 130 over 9. Your a value is, you don't know, so you can just leave a open. It seems like you're going to have to work out a and r simultaneously, and then after, while doing that, you just prioritize r. So here, a 1 minus r to the power 4, the whole thing over 1 minus r, right? So you have to work these out simultaneously. The one thing that you want to note is that you see here a with 1 minus r. That's something you also have here, a 1 minus r. So you want to be a bit creative in this situation, meaning here you can have a over 1 minus r. This is actually multiplied by 1 minus r to the power 4. This is what is equal to 130 over 9. So the big idea is, where you see this whole thing here, this a minus 1 over r, you can actually replace it with 18. You see, so here you can put 18 multiplied by 1 minus r to the power 4, 130 over 9. So when that is done, what now? You're gonna have, if you're gonna solve for r here, right? Let's see what you're gonna do. Solving for r, what do you get? Highball. Yeah, solving for r, you can just divide by 18 first, you know, because I was about to do something dumb. So let's see, 130 over 9 divided by 18, right? That's going to be 65 over 81. So this is like 65 over 81, 65 over 81. This is technically, this is going to cancel that. So this is like 1 minus r to the power 4. So this is better off if it's a positive value. So let's take it here. 1 minus this number. Let's see what we're going to get. 1 minus this number is going to be 16 over 81. Okay. Fortunately, this is a square number. This is a square number. Now here you can do some funny shandies, right? Where you can put like a square root symbol with the 4, square root symbol with the 4 here also. So what's going to happen here is you're going to have r here is equal to, let's see. This you can put in your calculator actually. So let's do here. Shift this with the 4 here, and then your answer. So that's going to give you 2 over 3. So this is like 2 over the 3. So that's your value of r. R is just 2 over 3. So this question, the only thing is, because this is a even number, you have to put a plus and a minus here, because that's just how it is. Just like when you work with the square root. When you do the square root of something, or the or yeah, when you do the square root of something, you have to put a plus or minus. So as long as what you're dealing with here is an even number, you have to put a plus or minus for your answer also. So that's that for that question. Okay, question number 3. Yeah, things are moving quite slow, but we're almost there. But anyways, you see everything we're doing, right? If you need more in-depth lessons on that, I suggest you sign up for the online courses. The link to that is in the description, but obviously you can always hit me up on IG if you need to ask like questions or something like that. I try my best to respond. But remember, I try my best to respond. I always respond. Sometimes it's just a bit late, but I do respond. Question 3 says black and white blocks. Okay, so this is kind of awkward because the black ones are these ones. Yeah, this is really kind of awkward, like super awkward. But I literally have to like recolor this whole thing here because it's actually a bit inverted. Remember, the colors are inverted, so whatever is black is these ones. You see, the other ones, the black ones are white, the white ones are black. So yeah, that is the awkwardness of it. So we just need to be conscious of that. So it says the black and white blocks create a pattern. The first 3 patterns are shown below. So obviously there's 5 blocks that are black here. Here it's like 4, 5, 6 of them. Here it's like 5, 6, 7 of them, right? 5, 6, 7. It says write down the number of black blocks in each pattern. Really? Wow. 5, 6, 7. What a wow. How dumb. But 3 marks. So it says write down a formula for the number of black blocks that will be used in a pattern. So Tn is going to be equal to A plus n minus 1d, right? Because the common difference here is a 1. The first term is a 5. So n minus 1 with 1d. So if you want to simplify this, it's going to be 5 plus n minus 1. Well, you don't need to put the brackets. So it's going to be Tn is equal to 4 plus n. Yeah, that kind of makes sense. Anyways, it says here, how many white blocks will be used to create the 4th pattern? So here we can just keep track of the white blocks. So white blocks, it's 1, 2, 3, 4. So it's 4 of them here. White blocks, it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 plus 9, that's 18. So from 4 to 10, that's like you add 6. And then from 10 to 18, you add 8. I'm assuming the next one you're going to add 10. That's an assumption because it looks as though these differences here, they have a second common difference. So let's just say 10. No, not 10. If you add 10, so you see it's 10 here plus 8, it's giving 18. 18 plus 10 gives you 28. Let's say 28. See, we're going to say 28 because it looks like what we're dealing with here for the white blocks is a quadratic sequence. It says determine the formula for the number of white blocks. So we say Tn is going to be equal to A n squared plus Bn plus C. Now the sequence of the original sequence looked like this. No, it looked like 4, 10, 18. The sequence of first differences had 6 and 8. And then the second common difference would have had 2. So this is like equal to 2a, this is equal to 2, no, this is equal to 3a plus b. And then this is equal to a plus b plus c. Now the idea is 2a is equal to 2, right? So this is like 2a is equal to 2. Divide both sides by 2. You're going to have a as 1. And then what else? If a is a 1, you're going to throw 1 over there. Then you're going to have like b is equal to 6 minus 3. That's a 3. The last one here, you're going to have a is a 1, b is a 3, c is, what is c now? C is what you're looking for. So this is like 4 plus c. C is going to be 0 because the 4 here is going to go over. So here you're going to say, therefore, Tn is equal to n squared. B is like 3, right? Plus 3n. C is like a 0. So you're going to have nothing there. Yeah, here's what you have. 3.5, you're gonna have here, calculate how many white blocks will be in a pattern with 32 black blocks. Wow, what a wow, bruh. Yo. Okay, well here we have to think nicely. So we know that the sequence that has black blocks is given by this formula. So what we know is for 5 black, it's 4 white. For 6 blacks, it's 10, going on and on and on. So what we can do is, in the sequence of the blacks, we can find out where you have 32, the position of 32. So that when we find the position of 32 in the black ones, we can put that value in the formula for our white blocks. So you see, we want to see where we have 32 black blocks. So in the formula for black blocks, we know that this is just 4 plus n. So we want to find out where we have 32 black blocks. So let's find out the position of 32 black blocks. So that is basically 32 minus 4, that's like 28. Okay, what that means is, in this sequence now, we have to find out what is position number 28, because position number 28 gives us the number of blocks that are white. So we're gonna have here squared plus 28 here. So, yeah, let's see what we get here. We are getting something pretty interesting, I guess. So we're getting here 868. 868. That's T28. And that's the answer that we are getting. 3 point. Let's move on to the next question. You are going to be glad that you bumped into this ad, because we are hosting an in-person math grade 12 workshop. So the idea is, there's going to be 2 workshops, one in Bryanston and one in Pretoria North. The one in Bryanston is going to take place on the 18th of October until the 19th of October. The one in Pretoria North is going to take place on the 20th of October until the 21st of October. If you want to follow the proceedings online via Zoom, that will only cost you $3.99. The full details for that are linked in the description below. The main idea with the workshop is you will be able to ask very detailed questions with regarding anything metric related, actually. Applying for university, upgrading, taking a gap year, math questions, very specific, very detailed math questions. And the good news is, as long as you sign up for the workshop, you will also have access to the full online courses, meaning prior to the workshop, you will be able to go through the online courses so that on the day of the workshop, you are able to ask very detailed questions. So if you do opt to join in online, that will be from the 18th to the 19th, meaning you will be following along the proceedings that will be taking place at the Bryanston branch. The good news is, if you do sign up for the Pretoria in-person workshop on the 18th and the 19th of October, you will also be able to follow the Bryanston proceedings online via Zoom, meaning you'll be able to ask questions, I'll be able to see them directly, we'll be able to chat, we'll be able to gel. It is one of those things you definitely do not want to miss. Seats are super limited, so you can hop onto our website and check if there's still space available. Question number 4, it says, below are the graphs of f of x. F of x is a parabola. G of x is a hyperbola. And then it says here, h of x is equal to n, an asymptote of g. Wow, that's kind of weird. Oh wait, h of x is equal to n, so it means the y asymptote. Okay, so this one here. And then it says, no, this one here. This is the y asymptote of g, you see, because you see, we don't see any other dotted line. This dotted line is the line of symmetry for the parabola. This y-axis is the asymptote for our hyperbola. And then it says here, is also a tangent to f. Where is f now? What? Hypo. Tangent to f. Hypo. This, oh, no. This is one of the, this is the line h, yeah, because it passes the y-axis. So the y value here is n, for future reference. And then it says the is also a tangent to f. Yes, that makes sense now. So it means if the point here, if this point is the turning point and they say the y value is a 7, it means that n would also be a 7. But let's keep reading. It says here the line r, which is this straight line here, is an axis of symmetry of G. So what they actually mean is this is a line of symmetry, yes, for G, which is interesting because remember this line here, the line that they're talking about passes through a point where the asymptotes meet. Now, if they told us, oh, wait, this is the E value, and then up here, this Y value has to be 8. The reason why that Y value is 8 is because the Y value here is 8. The y-intercept of the straight line is 8. So this here says r is equal to x plus 8 also intersects the axis of symmetry of f in this point. So this straight line also eventually cuts the line of symmetry here. Okay, fine. So it says write down the domain of G. What kind of a graph is G? G is a hyperbola. So any hyperbola, the domain will always be x as the element of r, excluding the asymptote. So here, x is the element of r, but then your x value cannot be equal to 0. You see, because it looks like the x asymptote is at 0. So the next one says calculate the value of m. M is equal to 8. We worked it out by saying, no, n is 8, not m, bro. Come on now, come on, man, come on. M is the x value here of the line of symmetry. So that's going to be interesting. Whew, okay, well, what do we know? What we know about our parabola is that this is the P and coordinate Q. This will be the turning point. You see. Now the thing though is in this equation we can put in multiple pieces of information. No. We actually cannot because the y value is Q is a 7, but now for M. Yeah. Oh no. This is easy. The y value here is a 7, so we can get the x value for the straight line. So in the equation of the straight line, right? We're gonna put y as 7. So this here in the equation of the straight line, right? X plus 8. The y value we're putting it as 7. So this is gonna be x plus 8. The 8 is gonna go over 7 minus 8 gives you a minus 1. So the x value is a minus 1. So if the x value is a minus 1, it means m is equal to minus 1. The m value here, this is the one that's equal to minus 1. So that is all nice and dandy. That is all nice and dandy. Okay, what's the next thing here? Oh yeah. So we got m. M is equal to negative 1. For n, what did we say about n? We mentioned that n is the y value of the straight line. So if we already know the y value of the straight line, it just means that n is equal to 8. So that's just fine because that's just a 1 mark question anyways. The next one, it says given f of x is equal to this, write down the values of p and q. So we already mentioned that we know what p is. I mean, we know what q is because q is the y value of the turning point. So the y value of the turning point here is 8. The x value is a negative 1. You see, because whatever x value we have over here, it's the same x value up there. So what we know is the p value, when you drop it in there, p is actually going to be equal to, well, this is where it gets tricky because in your, wait, I have to put here 8. On the Cartesian plane, right, we can see that this value is like negative 1. So on your equation, this has to be a plus 1. You see, you have to drop a 1 over here. And then for q, we already know it is positive 8 over there. So let us move on to the next question. The next question, how many marks? The next question is out of 3. It says, if it is given that f of x is equal to this equation, calculate the x-intercept of f. Okay, that's a bit weird. but it doesn't matter because we can always just use the quadratic formula. So yeah, we can either use the quadratic formula, or we can take out 2 as a common factor, or we can actually take out -2 as a common factor. Whichever way you want, it's going to work out. So let's actually take out what you may call -2 as a common factor. So if you make this equal to 0, the reason why we're taking out -2 as a common factor is because it's easier to work with the a value that's a positive. So if you take out a -2 here, x squared plus 2 over there, 2x, and then this is going to be -3, and then this is equal to 0. And then both sides are going to divide by -2. So if you divide by -2 on the left and on the right, you're going to get here 0 is equal to x squared plus 2x minus 3. So fortunately, this we can factorize because it's just a normal basic trinomial. So we're going to have 2 brackets that, let's see, 2 brackets, factors of 3 that gives us a 2. It's just 3 and 1. Since we have a plus 2 here, we're going to say a plus 3 minus a 1. And this is x and this is x. And then technically, this is going to give us x is equal to -3, or x is equal to +1. Okay, let us keep it moving. So with the next question, right? Wait, are we done here? Yeah, we just had to calculate the x-intercept. So x-intercepts are actually like, yeah, I think we're done here. Moving on to the next question. For 2 marks, it says the axis of symmetry of F intersects the graph of G at point D. Determine the coordinates of D. Where is D? You can actually check that in the image. Okay, fortunately, D is a point where the x value is a -1. So to get the y value, we can just use the equation of our graph of G. So remember, n is 8. So let's see what we can do now. If you're going to throw x as -1, let's actually write it down over here. G of x, where x is, we're going to throw in -1 over there. And then this is going to be, what is this going to be? It's going to be -3 over x. So this is like -3 over x and then plus 8. But then we say the x value is like a -1. So we're going to throw -1 over there. -3 over -1, that's like a 3, plus 8, that's like 11. The y value is 11. So it means that the d value, or the coordinate of d, is -1 and 11. There we go. Nothing crazy, nothing major. So for 5 marks, it says, okay, so obviously a 5-mark question, we need to be a bit careful. So for 5 marks, they said, determine the equation of the tangent to G at D. Write down your answer in the form blah, blah, blah. This is an equation of a straight line. So the equation of the tangent to G at D. So your tangent would actually look something like this, you see. So what we need to do is we need to figure out what gradient we would have over here. But the fortunate thing is this purple line would actually need to be parallel to the graph R. The reason for that is that's the only way a tangent can be at point D here. It's just also a bit of intuition that you need to be using for you to answer this kind of a question. So in this situation, we're gonna use our but no. Let's actually not. We cannot assume that these are parallel. The reason why we're not gonna assume that they are parallel is because we can work out the gradient at this point if we need it, since we do need it actually. Because remember, if a tangent is going to pass D, it means that that tangent is going to have the same gradient as this point. And we can get the gradient at that point using first derivative. So let's see, the equation of G, let's write it out first. G of x is equal to what? G of x is equal to x. What is it again? It's -3 over x. -3 over x and then plus 8. So if you want to differentiate this, right, we have to take the x up first. So it's going to be -3 X is a negative 1 plus 8. This is g of x. And then if you differentiate now, differentiate to get the gradient equation, we are going to get the following. So let's see here. This is going to be positive 3, x with like a negative 2. And then this is like the derivative of a constant, it just falls away. Now what we want is the gradient where x is a negative 1. So this is going to be negative 1 here, negative 2. This is going to go down. So the gradient is actually a 3. So if the gradient is a 3, now what we know is in the equation of a straight line, y minus y1 equals to mx minus x1. Since our tangent passes through D, it means that D is the coordinate that we're going to put in our equation to try and get the equation of our straight line. Our gradient is a 3, and then our x value is a negative 1. So if you put a negative 1 there, it becomes a positive. So that's a plus 1. And then the y value is a 11. If you multiply inside, you're going to have 3x plus 3. The 11 comes over. That's going to be plus 11. And then you're going to have 3x plus 14. And that is the way we like it. Whew. Okay, that's not so bad. The next question, which is the second last question for question number 4, what is it asking us there? It says determine the equation of k of x. K of x is this equation. It's a hyperbola. If k is the reflection of g about the line x is equal to 2. Wow. Okay. Where is g? G is our hyperbola. The line x is equal to 2 would be a line somewhere here. Yo? Yeah, let's actually use a different color, totally different color. Maybe like a red. So the line x is equal to 2, right? Would be like somewhere here. So with a situation like this one, we have to be very, very careful. The reason why we have to be careful is because, I mean, we just have to be. So if you don't want to overthink it, right? Remember, let me actually copy this thing here and psychoanalyze this question. It's out of how many marks? This is a 3-mark question. Okay, yeah. So the reason why it's a 3-mark question is because most of what we're going to actually do, we just have to work it out by observation. Like we just have to like look and see what we need to see, and then we'll be fine. So let's see here. Goes up, down. There we go. So let's see here. So all this being done, right? Let's see what we need to do. So if you think of the line x is equal to 2, it's the line somewhere here. Now, if you reflect this graph about this purple line, logically speaking, right, you have to think to yourself that you see this curve here, right? This portion here would be somewhere here. You'd see it like that. You see, let me actually draw it nicely. You see something like this, you see, because this portion has to be like that. And then what you see over here, we would need to see it over there. You see? So because you're reflecting it about this purple line here, we can actually make it a bit brighter by making this like a yellow, you see. So if you're gonna reflect it about the yellow line, it basically means that you see this white curve here, you'll have a pink one over there. And this white curve here, you'll have a pink one over there. Now, the idea is, if you think of it nicely, your original asymptote is at 0. You see, the distance between 0 and 2 here is just 2 units. So your new asymptote would be somewhere here, which would technically be at 4. Because you see, if this is a 2, this also has to be a 2. Now, the y asymptote is going to stay the same. You see, it's still at 0. So for the pink graph, the y asymptote is also still at 0. So what we know is S here is going to be the y asymptote, right? We know it's still a 0. And then the x asymptote, we know it's a 4 here. So this is going to be a negative 4. To get the a value, we have to find a point that the graph passes through. And fortunately, a point that the graph passes through, we can get it from D. You see, this point is going to be somewhere there. So D, the x value is a -1, the y value is an 11. So from -1 to here, the distance is like 3 units. So from here to there, the distance is also going to be 3. So the x value is a 5. And then the y value is an 11. So here it's also going to be 11. So this is a point that the graph passes through, and we can use that to get A. So y value here, we can make it 11. A is what we're looking for. X value is a 5. And then the value here is a 0. So working out A, it's going to be 5 minus 4 there. That's just a 1. And then A is a 11. Whoa. Whoa, is that what it is here? No. That doesn't seem right. Why does it not seem right? It just doesn't. Because this is like -3. You're now -3. And then here we're getting a whole 11. Yeah, it kind of seems a bit shady, but yeah, it does seem a bit shady. It doesn't just seem shady, it seems all the way shady, because we have a 0 there, we have a minus. Why did I say 0 here now? Y-intercept. Reflection. Determine the equation of K if this is equal to K is a reflection of G about the line X is equal to 2. What? Reflection of G about the line X is equal to 2. Ha! Yeah, this is what I would say. I would say Q of X is equal to positive. Yeah, but I don't know why this is an 11 though. It shouldn't be so different. So yeah, that's why I'm a bit skeptical about the A value. The y asymptote, yeah, it's also. Oh no. This was an 8, bruh, not a 0. I think because it's a solid line, that's how I was a bit confused. But yeah, this is a +8 here. Okay, that makes life a bit easier, because now everything makes sense, because the 8 here now is going to be A over 1 plus 8, right? And then this is equal to 11. And then you're going to have 8 move over to the other side. So you're going to have 11 minus 8, which is a 3. Whew, that makes better sense. K of X is equal to 3, X minus 4, and then plus 8. There we go. So yeah, this solid line here, I don't know why it's solid. It's actually supposed to be a dotted line, but it is what it is. This one is the line Y is equal to 0. But it's fine. Let's move on to 4.9 now. Okay, anyway, so what I was saying is, let's see, 4.9. 4.9 says determine the values of K for which the equation of bx plus 4 plus K is equal to 0 will have a root that is less than -5. You are going to be glad that you bumped into this ad, because we are hosting an in-person math grade 12 workshop. So the idea is there's going to be 2 workshops, one in Bryanston and one in Pretoria North. The one in Bryanston is going to take place on the 18th of October until the 19th of October. The one in Pretoria North is going to take place on the 20th of October until the 21st of October. If you want to follow the proceedings online via Zoom, that will only cost you $3.99. The full details for that are linked in the description below. The main idea with the workshop is you will be able to ask very detailed questions with regarding anything metric related, actually. Applying for university, upgrading, taking a gap year, math questions, very specific, very detailed math questions. And the good news is, as long as you sign up for the workshop, you will also have access to the full online courses, meaning prior to the workshop, you will be able to go through the online courses so that on the day of the workshop, you are able to ask very detailed questions. So if you do opt to join in online, that will be from the 18th to the 19th, meaning you will be following along the proceedings that will be taking place at the Bryanston branch. The good news is, if you do sign up for the Pretoria in-person workshop on the 18th and the 19th of October, you will also be able to follow the Bryanston proceedings online via Zoom, meaning you'll be able to ask questions, I'll be able to see them directly, we'll be able to chat, we'll be able to gel. It is one of those things you definitely do not want to miss. Seats are super limited, so you can hop onto our website and check if there's still space available. So the one thing you want to recognize is them giving me this x plus 4 here. It's already telling me that the graph is being moved 4 units to the left. And then the value of k is a vertical shift. You see, more like the moving the graph like up or down or whatever. So what you want to do is you want to visualize this kind of equation in terms of you visualizing how you're going to answer it, in terms of you like figuring out what they're asking and how you're going to work it out. What you just want to do is if this graph moves 4 units to the left, right, your instead of your asymptote being here at 0, it's going to be somewhere at negative somewhere at negative 4 somewhere here. This is where your asymptote is going to be, right? Now that's your x asymptote. The y asymptote is still going to be where it originally is. We need to keep in mind that this is originally at 8, so that's not going to change. So there's 8 over here, there's 0 over here. Now the idea is, and then this is going to be negative what? Negative 4. So what you want to recognize is your new hyperbola, right? You're gonna have the curve over there. The other one you're gonna have it somewhere over here in yellow here. So the idea is if the x value here is like if the y value here is a 8 and then this one here is like a 0, what you want to recognize is they're asking you how many units downwards technically do you need to move it for it to have roots. A root is an x-intercept. So they're asking how many units downwards you need to move it for it to have an x-intercept that is less than negative 5. So the idea is, if you look at your image logically, firstly, this line here, right, this curve, right, we know that it stretches all the way to negative infinity. So for it to have roots or x-intercepts that are less than negative 5, it means that this portion of the curve, right, would need to be touching your x-axis anywhere on this far left side here. Because anywhere on the far left here, what you already know is somewhere here, right, you might have an x value of like negative 5, and then everywhere else is values that are less than negative 5. So what we already know is if you move your whole image, you see, if this whole image here is to move downwards, for it to start to have x-intercepts that are less than negative 5, you need to move it downwards a minimum of anything just above 8. Because if you move it 8 units, it's still not touching the x intercept. But if you move it anything just above 8, it's gonna start touching the x intercept. It's gonna be touching the x intercept until a certain point where the x intercept will specifically be what you may call negative 5. Because if you keep moving it downwards, it would then not have x intercepts that are less than negative 5. So the reason behind us saying we need to move it downwards at least 8 units is because initially the asymptote is at 8. So if you move it exactly 8, it will still not have any x-intercept. But the moment you move it anything above 8, it's going to start having x-intercept. And those x-intercepts are going to be x-intercepts that are below negative 5. Until you keep moving it downwards until the x-intercept is exactly negative 5. That's where you know your limit is. So what we do know is you need to move it down at least 8 units down, right? So here we're going to say your value of k is, if you're going to be moving your graph downwards, right, k needs to be a negative number. So you're going to have to say k, you have to move it down more than 8 units, remember. So k has to be smaller than negative 8, you see. Because k being smaller than negative 8 means you're moving it downwards at least 8 units. So you're moving it downwards more than 8 units. Now you need to move it downwards up until the x-intercept is specifically negative 5. So what we need to do is we need to find out if you're going to move it downwards until the x-intercept is specifically negative 5. We need to find out what that k value would be. You see, because where the x-intercept is specifically equal to negative 5, if we use this equation, we can work out what the k value needs to specifically be, meaning that would be the lowest amount of units downwards that we would need to move our graph. So it may sound crazy, but this is how you do it. All this is saying is in the equation of g, right? we need to throw in x plus 4 where x is, and then to the whole thing we need to add k. So the original equation of g, let me just, this is portion of our answer, right? So original equation of g looks like g of x with negative 3 over x, right, plus 8. So if you're gonna say x plus 4 plus k, it means that wherever x is, let's see here, g, x plus 4, and then the plus k part. This thing here, what you know is it is equal to wherever x is, you're gonna put x plus 4. And then after that, the whole thing, you're gonna add a k. So this equation here, what you know is that in this equation, you wanna find out a k value where the y value is a 0, because specifically where it's gonna be touching an x-intercept of -5, the y value is a 0. So you're gonna be making this equation here equal to 0. -3 x plus 4 plus the 8 plus the k. And then you can solve for k here. But apart from you solving for k, remember where this is a 0, the x value is a -5. So here you're going to have -3, -5 plus 4 plus 8 plus k equal to 0. And then here solving for k, you can see the -5 plus 4, that's -1. And then, what is this now? -3 over -1, that's like +3. And then here, this is, if you move it over, you're going to get a -11. That's what a k, that's what your k value is. So it means the lowest units downwards that you can move it is 11 units, because specifically when you move it 11 units downwards, the x-intercept is going to be equal to what you call, is going to be equal to -5. So that's the most amount of units, the most amount of units you can move it downwards is anything just before 11. You see. So here we're saying k has to be bigger than what you call, I mean, k has to be smaller than -8. However, k also needs to be, what we say, k has to be smaller than -8, right? But then those same k values need to be bigger than -11. Not saying bigger than or equal to, because specifically if you move it specifically 11 units downwards, the roots will not be less than -5. The root will be equal to -5. So we want it to just be before the -5. So it's going to be between -8 and -11. Honestly speaking, this is what I refer to as a wildcard question. Wildcard question means this is the kind of a thing where if you get like a 97 or a 96, maybe you lost the 3 marks here. You see, it's a wild card question. So you don't want to overthink it. You don't want to think yourself, if you're not getting it, then there's something wrong with it. Nope. You can listen to this portion of the video twice or whatever. You'll start to see the method of the madness. But anyways, there's one thing I definitely can emphasize. It is the workshop that we are hosting on the 18th of October to the 19th of October in 2022, obviously. So in person, it's this amount. Online, it's this amount. Now, in person, it's at 22 on Sloan, 22 Sloan Street, in Bryanston Center. So come on, man. And turn 2191. That's the address. Obviously, for queries, you can always just hit me up either on WhatsApp on 063-971872, or you can call on 083-866-0417. One of these two will be 100% A-OK. But anyways, let's move on to the next question. Okay, question number 5 says the following. Sketched below your other graphs of f and g, right? F is a parabola, G is an exponential graph. Then it says A is this point over here. It lies on the graph of G. 5.1 is asking us to get the inverse of F. So F is a parabola. So if you're going to get inverse, you have to swap around X and Y. So where Y is, you're going to put an X there. Where X is, you're going to put a Y there. So this is like 2Y squared. So making y the subject of the formula here, we're going to divide both sides by 2. you're gonna have x over 2 equal to y squared. And then since we want to make y the subject of the formula, you're gonna square root both sides, and then you're gonna put plus or minus as the answer. So y is gonna be equal to plus or minus square root of x over 2. That's going to be your inverse. But then in a situation like this one, yeah, you have to keep in mind that the way you're going to answer this question, you can see here that they specifically told us, we can see that here our y values are above 0. You see, we can see that for this equation, the y values of our graph are above 0. So for the inverse, here what we know is for this graph, right, the y values are bigger or equal to 0. So for the inverse, the x values have to be bigger or equal to 0. Because remember, whatever is y becomes x when you work out the inverse. So let's not forget that. So with what? Yeah, so moving on to the next question. For 5.2, it says the following. For 3 marks, for which values of x will this be between negative 2 and 0? Where will the inverse be between negative 2 and 0? So this is technically asking where are the y values bigger or equal to negative 2 or smaller or equal to 0. Okay, yeah, so the thing is, fortunately, you have the original graph G here, right? So you can see here the x value is like a negative 2, the y value is a 9. So the idea is the inverse of this graph, you will have a dotted line somewhere here. See, like that. This is the line of inverse. So since this is the line of inverse, right, what we know is the inverse will look something like that. It's because this part here and this part have to be a reflection of each other about this blue line. So if you have a point there, negative 2 and 9, you're going to have those coordinates swapped around, meaning somewhere down here, you're going to have an x value of 9 and the y value of negative 2. So if they're asking where the y value is between negative 2 and 0, what you already know is there's a y value of 2 here. Negative 2 here, there's a y value of 0 over there. So all we need to do is to find out the x value here, because our answer, we're going to say specifically from this x value until this x value. That's where your graph is going to have y values between 0 and negative 2. So fortunately for us to find this particular x value here, we can actually just find this y value, because whatever this y value is, it's going to be whatever this x value is going to be, because that's how inverse works. So let's see. So this is like to get this value here, we have to make x equal to 0 in the original equation. So g of x, if x is a 0, we're going to have a third to the power of 0, which is just a 1. So what that means is if this y value is a 1, it means that this x value here has to be a 1 as well. So what we know is our graph is between negative 2 and 0, starting from where x is a 1 up until where x is a positive 9. So obviously, if these kinds of questions are a bit tricky or crazy or however, then obviously you want to sign up for the online courses. But then which question is this one now? 5.1. Oh, I think I got the inverse of G instead of getting the inverse of F. Okay, I'll just do 5.1 again just now. But for now, what is this? We're gonna say x is bigger than or equal to 1, or x is smaller or equal to positive, is it positive 9? Yeah, positive 9. But then obviously in the previous video you saw I did 5.1 correctly, but obviously this was recorded after the fact, so hence you're seeing this here, but I obviously corrected it just now. But anyways, let's move on to 5.3. 5.3, what does 5.3 say? 5.3 says we should simplify this equation. You are going to be glad that you bumped into this ad, because we are hosting an in-person math grade 12 workshop. So the idea is there's going to be 2 workshops, one in Bryanston and one in Pretoria North. The one in Bryanston is going to take place on the 18th of October until the 19th of October. The one in Pretoria North is going to take place on the 20th of October until the 21st of October. If you want to follow the proceedings online via Zoom, that will only cost you $3.99. The full details for that are linked in the description below. The main idea with the workshop is you will be able to ask very detailed questions with regarding anything metric related, actually. Applying for university, upgrading, taking a gap year, math questions, very specific, very detailed math questions. And the good news is, as long as you sign up for the workshop, you will also have access to the full online courses, meaning prior to the workshop, you will be able to go through the online courses so that on the day of the workshop, you are able to ask very detailed questions. So if you do opt to join in online, that will be from the 18th to the 19th, meaning you will be following along the proceedings that will be taking place at the Bryanston branch. The good news is, if you do sign up for the Pretoria in-person workshop on the 18th and the 19th of October, you will also be able to follow the Bryanston proceedings online via Zoom, meaning you'll be able to ask questions. I'll be able to see them directly. We'll be able to chat. We'll be able to gel. It is one of those things you definitely do not want to miss. Seats are super limited, so you can hop onto our website and check if there's still space available. Okay, so this is just the inverse. This is just the original equation of f, and then this is just the equation of f if you have put 1 over x in the equation. So the one thing you might want to do for yourself is to just refresh your memory on what the equation of f looks like. It's just 2x squared, just like 2 here, x squared. So the idea is, let's see, wherever x is, right, what are we going to do? This is saying in the equation of f, wherever x is, put 1 over x there. So this is 2, and then you're going to put 1 over x, and you're going to square it. This is saying you're going to put 1 over the equation of f of x, which is 2x squared. And then this is saying whatever the inverse is, you're going to square it. So if you square the inverse, it means you don't have to worry about the whole plus or minus thing. You can just use the positive version of it, because anything squared will always come out as a plus. But anyway, square root and the square, it means the square root cancels out. So here, 1 squared is a 1, x squared is x squared, and then 1 over 2x squared. So here, anything under square root, if you square it, these cancel out, right? So you're going to have plus x over 2. Since they want us to simplify, let's see how far we can go. This is going to be 2 over x squared plus 1 over 2x squared plus x over 2. And then what are we going to do? The denominators, we need to get an LCD. So the LCD here is clearly 2x squared. So here we have to multiply by 2 over 2. Here we have to multiply by x squared over x squared, so that they all at least have one denominator. So this is going to be 4 plus 1 plus x to the power of 3, the whole thing, over 2x squared. So this is going to be 5x cubed over 2x squared. I think this is what we are going to get in its simplest form. We might as well leave it like this, because I think going anywhere further, it doesn't seem like it's going to happen right now. So that's for this question. That's for question number 5. Let's move on to question number 6. Question number 6 is quite interesting. Okay, no, it's not that interesting. It's just financial maths. But it says here, on January the 1st, 2022, Pete decided that he will buy a cottage near the sea in 11 years' time on December the 31st, 2032. The cottage will cost him $1,800,000. He opened a savings account in order to save to buy the cottage. The bank offered an interest rate of 13% per annum compounded monthly. Pete made his first payment into the account 1 January 2022 and continues with payments at the end of each month thereafter until December 2032. Calculate the effective yearly interest rate. So The interest rate they gave us here is 13%, right? So we can just use the effective rate interest formula. So it's I EFF plus 1 is equal to 1 plus I nominal over M, the whole thing to the power of M. So we know that M represents how many times the money is compounded yearly. So here it says 13% per annum compounded monthly. So it means our value of M is equal to 12. And then our I nominal is equal to 13. There we go. No, 13%. So the percentage symbol, you definitely would need to use it if you are going to do what? Yeah, you're definitely going to need to use it if you're going to, if you're not going to write it as like 0.13 or a fraction. So let's see. This, the effective rate interest formula, you're going to have the 1 move over to the other side. So it's going to be 1 plus 13%, the whole thing over 12, the whole thing to the power of 12, and then minus 1. So all this in your calculator, let's see what it is going to give us. So it's going to give us 1.13. I usually write it to 5. No. Don't round off first, right? The whole thing. Write it out first. And then you can round off to 2 decimal places afterwards. So this is 482. And then if you multiply by what you call, you have to, no, this here, this is before you, no, if you minus 1, you're going to have 0 point something here. And then when you multiply by 100, you're going to have 13.80%. This is like IEFF. And then the next thing is question 6.2, right? 6.2 says the following: calculate the monthly payment. So the monthly payment, well, this is not very crazy because it's just a normal, what you may call. There's nothing crazy about this question. You see, the reason why I say there's nothing crazy about this question, well, we have to be careful now. It says in 11 years' time, but he opened a savings account, blah, blah, blah. The bank offered him this much. They said he made his first payment on January the 1st, 2022, which is on the time he opened the account. So the idea is, right, the number of payments that he's going to make, it's going to be 11 times 12, right, which is 132. However, on the day he opened the account, he made a payment also. So we have to add that payment, which is going to give us 133 payments in total. So what we know is, in this situation, right, we know that f is equal to x 1 plus I to the power of n minus 1, the whole thing over I. And then, let's see here. And then what? The whole thing over I, right? So what we're going to get here is f is equal to, what is the x value? Well, since we're looking out for x, we can actually make x the subject of the formula. So here, making x the subject of the formula, we would multiply by I, multiply by I. So this is like fi equal to x 1 plus I to the power of n minus 1. And then divide everything by this big bracket. So you're going to have x is equal to fi, the big bracket, you're going to have 1 plus, I'm just writing, I hope this does not confuse anyone, but then all I did was I wrote x in front here and then just divided everything by the big bracket so that it looks normal. So let's see here, our value of f is 1,800,000. Our value of I is what? 13% per annum compounded monthly. So it's going to be 13% over 12 since it's compounded monthly. And then 1 plus 13% over 12. N is like what? 133 minus 1. So everything put in the calculator, 1,800,000. And then we're going to have here what? What are we going to have here? Let's see what we're going to have here. Da 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 da. Hi, yeah. Okay, so putting all this in the calculator, let's see what we are going to get. The value of x here is going to be equal to 6,109.77. And then, yeah, nothing crazy here. The next question, right, says Pete decides that he will go on a holiday to the Kruger National Park on 31 December 2026. And then it says here, so he's going to go to the Kruger National Park December 2026, and then December 2028, December 2030. He will withdraw 20,000 from the savings account each time he goes on holiday. These withdrawals will result in Pete having the required amount to buy the cottage on 31. These withdrawals will result in Pete not having the required amount to buy the cottage on 31 December 2032. How much will he be short of to buy the cottage for 5 marks? Well, the idea with a question like this one is, yeah, we have to be careful. So it's kind of like a long one. When I say it's kind of like a long one, I literally mean that we need to take into consideration that the 20,000 that he is going to be withdrawing, right? Like one or the other, it's going to it's going to take away from the 1,800,000 that he would have at the end of the 133 months. So what you need to keep in mind is when he withdraws the first 20,000, right? When he withdraws the first 20,000 here, he is technically robbing himself of about, let's see, because remember initially it's from 2000 and what? This is the logic behind this. This is from 2022, right? From 2022 until 2026. This is after 4 years, right? So 4 years have passed. Now from 2026 all the way until 2032, you have to remember he has forfeited how many years of that 20,000 accumulating interest. So it's like 2027, 28, 29, 30, 31, 32. So for the first 20,000, he has lost 6 years where this 20,000 could have been gaining interest. And then when he takes out another 20,000, he takes it out in 2028. So from 2028 to 2032, this would have been 4 years, right? 4 years where the 20,000 would be gaining interest. So he forfeits those 4 years where this 20,000 could have been gaining interest. And then the third and final one, which is in 2030. So what we know is 2030 until 2032. This is like 2 years, right? So what we already know is he forfeits 2 years where his 20,000 could have been gaining interest. You are going to be glad that you bumped into this ad because we are hosting an in-person math grade 12 workshop. So the idea is there's going to be 2 workshops, one in Bryanston and one in Pretoria North. The one in Bryanston is going to take place on the 18th of October until the 19th of October. The one in Pretoria North is going to take place on the 20th of October until the 21st of October. If you want to follow the proceedings online via Zoom, that will only cost you $3.99. The full details for that are linked in the description below. The main idea with the workshop is you will be able to ask very detailed questions with regarding anything metric related, actually. Applying for university, upgrading, taking a gap year, math questions, very specific, very detailed math questions. And the good news is, as long as you sign up for the workshop, you will also have access to the full online courses, meaning prior to the workshop, you will be able to go through the online courses so that on the day of the workshop, you are able to ask very detailed questions. So if you do opt to join in online, that will be from the 18th to the 19th, meaning you will be following along the proceedings that will be taking place at the Bryanston branch. The good news is, if you do sign up for the Pretoria in-person workshop, on the 18th and the 19th of October, you will also be able to follow the Bryanston proceedings online via Zoom, meaning you'll be able to ask questions. I'll be able to see them directly. We'll be able to chat. We'll be able to gel. It is one of those things you definitely do not want to miss. Seats are super limited, so you can hop onto our website and check if there's still space available. So what you need to do is you need to take into account all this money that he has forfeited. So what you do is the first 20,000, right? It would have gained interest for 6 years. So what we need to think to ourselves is the compound interest formula: A is equal to P 1 plus I to the power of N. What we do know is P is 20,000, right? 20,000. It would have gained interest for 6 years at 13% per annum compounded monthly. So this is 13% per annum compounded monthly. 6 times 12. Let's see what that is. 6 times 12 is what? 6 times 12 is 6 times 12. 6 times 12 is like 72. So this is like 72. 72. And then let's see what this would have accumulated to. 20,000. And then we have the 1 plus 13 shift percent over 12. The whole thing to the power of 12. This is like 20. He forfeited 22,760.64963. That's for the first 20,000 that he took out early. For the second 20,000, right, you have to remember that he forfeited how many years? He forfeited 4 years. So 4 times 4 times what? 4 times the 12 would have given him 48 months. This is like 48 months that is forfeited now. 48 months of interest that is forfeited. So this 20,000 here, 1 plus 13 shift percent over 12, the whole thing over 48, right? This is like 33,546.60901. Now the third amount that is forfeited is 20,000. 1 plus 13%. Let me see here. Let me carry on. So here it says 1 plus what? 13%. Yeah, so this is 13% over 12. So let's put here 13% over 12. For the last payment, the number of payments that were forfeited, right? It's basically 2 times 12, which is like 24 months that were forfeited. So this is going to be equal to, in the calculator, let's see what this accumulates to. Let's see here, 24. This is like 25,902.35858. So the big idea is these three, right, put together. So here you can say here, therefore, the total amount is these three put together. 1, 2, 3 added up. You see, you plus this one, you plus this one, you plus that one. This plus this plus this. Let's see what the total is in our calculator here. This plus the next one. In our calculator, the overall total is 100. No. Doesn't make any sense. 6 times 12. Is it 72? I think there's an error there. Wait. Yeah, there's a mistake I made here. I think this was, let me see, because it can't be that much. Too little. 72. Oh yeah. What? How did I write this number now? So incorrect. So weird. But anyways, at least we saw it. It's like 43,446.81479. 81479. This is the the whatchamacall. These are the three numbers we're going to add up. So adding up these three, that's what we're getting. 100,000. This is 100,000. This is 102,895.75. There we go. There we go. So with that being done, let's move on to 6.4. 6.4 says, calculate the new monthly payment into the savings account over the 11 years that Pete will, the monthly payment that will allow Pete to go to his holiday and buy the cottage. So in this situation, what you need to keep in mind is, right, his original monthly installment. What we need to keep in mind is that all that's going to happen is the money that he has forfeited, right? We need to almost think to ourselves, okay, fine, whatever happens in these months, if he wants to be able to take out this money, he just needs to make provision for it in the beginning of his investment period. So instead of him aiming towards having this much in the account to begin with, he should aim to have that much plus the 102,895.75. Because what's going to happen is, even though he will be gunning for this amount, right, what happens is, as he's going to be taking out those 20,000s, he's going to be taking out this amount over an extended period of time, meaning at the end of the 11 years, he will just have this balance instead. So this is the two amounts we need to add up as our F value. So our F value is going to be this amount. So the new X value, X, is going to be equal to F times I, right? And this is 1 plus I to the power of n minus 1. And then in this situation, we know, what do we know? We know that F is what? This is technically going to be 1,902,895.75. Interest is still 13% per annum compounded monthly. And then here we have 1 plus, what is the interest? 13%. It's like 13% over 12. This is like 133 minus 1. And then what now? Yeah, so now we can just put all this into the calculator. Putting all this into the calculator, let's see what we get. Let's see here. Okay, yeah. So in the calculator, we're getting here 6,459.03. That's the final answer, which is okay, not bad at all. It's not too far from his initial one anyways. It's literally just like almost 300 rand more. So not bad, 300 and something. So let's move on to question number 7. So we know if you're going to determine anything from first principles, we have to use this equation. F prime is equal to lim h goes to 0 fx plus h minus f of x, right? The whole thing here over h. Now the big idea is the following. So in this kind of a situation where f of x is, right, wherever x is, you have to put x plus h in there. So what this is going to look like is this, x plus h. What you can do is get an expression for x plus h first, and then you can minus f of x. So this here, it means wherever x is, I'm going to throw x plus h, that's squared. And then here x plus h, and then plus 3. And then what? You're going to have 5 here, x squared plus 2xh plus h squared. And then you're going to have minus x here, minus h plus 3. So if you carry on some more, it's going to be 5x squared plus 10xh plus h squared minus h plus 3. So you can see this basically, yeah, it's just a huge expression that is not necessarily very useful. But let's see. F prime looks like this. F prime, right, is gonna be equal to lim h goes to 0. The whole h goes to 0 part, you have to keep that there all the time. So let's see this whole thing here. Let me copy. Let me paste this thing here. Let's see what we're gonna do. What you're gonna do when they come for you. So this is what you need to keep in mind. This whole thing here, right? This is what the whole fx plus h is equal to. You see. So let's maybe put that in green so it pops. So once you put this here, right, we know that you're supposed to subtract. This is where you just need to be careful and you just need to use logic. You see, you're gonna subtract this. So if you're subtracting it, it means this is gonna be negative 5x squared. Since it's a minus here, it's gonna be a plus here. Since it's a plus there, it's gonna be a minus here. Now the big idea here is everything that you're subtracting here, it has to be, you obviously need to, what you may call, it needs to cancel out if you've done what you've done properly. So you see the minus 3 cancels the plus 3, the x cancels the x, the negative this cancels that. And then here you're going to have lim h goes to 0. So you're going to have 10xh here plus h squared minus h, the whole thing over h. If you take out h as a common factor, lim h goes to 0. So h goes out, right? It's going to be 10x plus h minus 1. And then this cancels that. So you're going to have here lim h goes to 0. Then you're going to have 10x here plus h minus 1, the whole thing over. Oh no, that's gone. Oh yeah. So as long as that's gone, right, it means that you're doing whatever you're going to do now. It's not going to be what you call. Yeah, you're almost practically done right now, because in this situation, wherever h is, you can now throw a 0 in there. So here f prime is actually going to be f of x. A 0 goes there, right? Then you're going to have negative 1 there. So to double check your answer, you can see here, if you were to get f prime, right, using what? Let's see. If you were to get f prime, you would have said 10x minus 1. There we is go. Okay, so we have a differentiation question here. So I wanted to differentiate this expression. So the one thing you're going to need to do is you're going to need to put this in a format that allows you to differentiate properly. So the one way that we are going to be able to differentiate properly is if you multiply out your brackets, you see. So for example, you have here 2t times t, right, which is like 2t squared. And then you have 2t times the 4, which is like 8t. And negative 1 times t is like negative t. Negative 1 times that is like negative 4. There we go. So the idea here is that, let's see, 8 minus 1, right? That's going to give you a 7. So that's like 7t minus 4. So now this you can differentiate. So differentiating this, it's just, okay, once you're about to differentiate, we can leave out the d over dt there. So 2 times 2 is a 4. Remove 1 from the exponent. 1 times 7 is a 7. Remove 1 from the exponent, you'd have t to the power of 0, which is just a 1. So this is what you have after you have differentiated. 7.3 says we need to differentiate, but we have to think of q as the main variable actually. So whoa. So what we actually need to do here is we need to make sure that q is the subject of the formula first before you differentiate. That's what this means. You need to make q the subject of the formula, and then you need to differentiate in terms of p. You see, it's just like when you have dy over dx as a question. If the question is asking for dy over dx, your equation would normally start with y is equal to like something. You see, so that's why you would have dy over dx. Y would be the subject of the formula. So for this question to work out, you need to make sure that Q is the subject of the formula first. You are going to be glad that you bumped into this ad because we are hosting an in-person math grade 12 workshop. So the idea is there's going to be 2 workshops, one in Bryanston and one in Pretoria North. The one in Bryanston is going to take place on the 18th of October until the 19th of October. The one in Pretoria North is going to take place on the 20th of October until the 21st of October. If you want to follow the proceedings online via Zoom, that will only cost you $3.99. The full details for that are linked in the description below. The main idea with the workshop is you will be able to ask very detailed questions with regarding anything metric related, actually. Applying for university, upgrading, taking a gap year, math questions, very specific, very detailed math questions. And the good news is, as long as you sign up for the workshop, you will also have access to the full online courses, meaning prior to the workshop, you will be able to go through the online courses so that on the day of the workshop, you are able to ask very detailed questions. So if you do opt to join in online, that will be from the 18th to the 19th, meaning you will be following along the proceedings that will be taking place at the Bryanston branch. The good news is, if you do sign up for the Pretoria in-person workshop, on the 18th and the 19th of October, you will also be able to follow the Bryanston proceedings online via Zoom, meaning you'll be able to ask questions, I'll be able to see them directly, we'll be able to chat, we'll be able to gel. It is one of those things you definitely do not want to miss. Seats are super limited, so you can hop onto our website and check if there's still space available. So here you can take out a Q as a common factor first. So taking out Q as a common factor, you can actually take out a negative Q. So let's see here, 9p squared, right? If you take out a negative Q, you're gonna have negative Q here. And then here you're gonna have like 3p and then plus 1 equal to 1. And then, oh no, I think taking out a negative is a bad idea. Let's take out a plus. Then here you're gonna have a negative. Here you can have a negative. The reason why we're taking out a plus is because, I mean, like at the end of the day, we're gonna need to isolate Q as a positive. So the 9p squared can go over, like 1. 1 minus 9p squared, right, goes over to the other side. And then you're gonna have Q here, negative 3p minus 1. And then this is looking quite interesting. Divide both sides by this bracket, right? You're gonna have Q is equal to 1 minus 9p squared. The whole thing divided by negative 3p minus 1. So that's the big idea here. So with that being said, let's see here. With that being said, when you're gonna differentiate this now, you wanna be very careful because this is not the kind of a thing that you can differentiate very easily. I mean, like the nature of it, it's just, yeah, it is just crazy. The reason why I say it is just crazy is because it actually really just is crazy. Now, when you're gonna be dealing with something like this, how many marks is this question? It's a 4-mark question. I'm going to show you a trick. Now, this trick is something that you can actually use all the time. And it is as follows. So you see, this method may not work, but I'm going to show you something that is a bit intricate, but something you can use. So when you see that you have here 9p squared, right, minus 3pq, then you have minus q here equal to 1. The idea is, what you're going to need to do is, every time that you see something like this, you have 2 variables, right, and you need to differentiate, you need to get dq over dp. So what you know is there's a q here, there's a q here. And then what you do know is there is a p here and there is a p here. So in a situation like this one, right, we try to do what we tried to do. We tried to take out q and we did whatever we did, blah, blah, blah. Yeah, it just didn't work out. So what you need to do in this kind of a situation, right? Well, based on what we did up here, you can see that we have here the difference of 2 squares, because trying to find yourself going back to the beginning here, yeah, it's not going to work out. The difference of two squares at the top here, this is a square number, right? It's just a 1. Square number, it's 9 and p. That's going to give you 3p. So because there's a minus here, you're going to put a plus and a minus here. At the bottom, you have negative 3p minus 1. Now, the big idea is for you to have at least something that looks like what you have at the top, you're going to need to remove a negative 1 at the bottom, you see. So if you remove a negative 1 at the bottom, what are you going to have? Negative 1 goes out, right? And then you're going to have 3p here plus 1. So the fortunate thing is the 3p is a positive number and the 1 is a positive number. So this bracket and this bracket can cancel out. Meaning here, this bracket divided by negative, you're going to have negative 1 plus 3p. This is what q is equal to, you see. So now when you're differentiating, I mean like dq over dp, you're going to have, this is a constant, so it goes away. Differentiating this, you're just going to have a 3. Question number 8 says the following. It says, the graph of the second derivative is equal to this equation. So it says here, if the graph of the second derivative is equal to this, it's a straight line, right? Where your original graph of f of x looks like this, right? It's a cubic function. So we know that you start as a cubic function. If you differentiate it, you get a parabola. If you differentiate that, you get a straight line. They said here the graph of f is decreasing where x is between negative, and where x is between t and 1. So this is quite a very interesting question. This kind of a question, right, needs you to have your calculus knowledge in check, like proper. Fortunately, on the main channel, right, Bright Young Brains, there's a playlist that works on exactly what we're talking about now. Okay, so let's see what they say here. They're saying here, if they're saying this graph is decreasing from t until positive 1, if it's decreasing within that space, then we need to be careful, because so far the way this is laid out, we don't know if this is like a cubic function that looks like this, or if it's a cubic function that looks like this. But the best way to get an accurate idea is by looking at this second derivative, because this second derivative, you can see the gradient is a positive number. So this number is a positive number. So if you think of it logically, the first derivative of this question, right, is going to be 3px and then plus 2qx and then plus r. So in this kind of a situation, when you differentiate again, you're going to have the, this is squared actually. When you differentiate again, right, you're going to have the 6px, right? And then if you differentiate this, it's going to be plus 2q, right? And then this is a constant, so it falls away. So what you want to recognize is, because you can see that this is a positive gradient, it means that the p here is a positive number, because a positive number times the 6 is the only thing that can produce a positive gradient. And this m here, we know it's standing in the place of this 6p. So that's how you know that the cubic function you're initially working with goes up, and then it goes down and then up again. So if they're telling us that between t and 1, the graph is decreasing, that could easily be talking about, you know, one turning point there up until another turning point, because from one turning point to another, this is the only portion where your graph is like decreasing, you see. So already what this is telling us is the x value of this first turning point is a t, the x value of this next turning point is a positive 1. You see, literally. And all this knowledge, it's knowledge that you accumulate by going through the online courses on our website. The link to that is in the description. So you may be thinking to yourself, oh, he's just plugging himself. But dude, you literally just saw what we just broke down in a few seconds based on background knowledge. And you need that background knowledge, because as we're going to be working out these questions now, you'll see how things will just be a bit easier. So let's see. The first thing is they want us to determine the equation of the second derivative. So them asking the equation of the second derivative, that's just the equation of this straight line. So it's quite straightforward, you see, because the equation of the second derivative, firstly, we need to find the gradient of this line. We can easily get the gradient of this line because we have two coordinates given. There's an x value here, which is 0, y value 6. X value here, which is -1, y value 0. So these two coordinates can easily get us our gradient, which is m. So our m is going to be equal to 6 minus 0, 0 minus 1, so you plus. And then this is just 6. That's the gradient. So if m is 6, it means that p is just a 1, but that's a story for another day. Well, not another day, but a few moments from now, we'll be using that information. The y-intercept is a positive 6, so that's what c is. So here, therefore, second derivative gradient is a 6, and the y-intercept is a positive 6. It makes sense because this is quite steep, you see. This is just 1, and then this is like 6 upwards. So let's see what we have to do next. The next one is question number 1, 8.2. 8.2 says, write down the x value of the point of inflection. So writing down the x value of the point of inflection, we know that you have to just make your second derivative equal to 0. So our second derivative, we're going to make it equal to 0. And then here, going to have -6. Divide both sides by a 6. Going to have x as -1. Nothing crazy there. Now, 2 marks, it says, use the graph of the second derivative to determine the values of x for which f is concaved up. Give a reason for your answer. Being concaved upwards or being concaved downwards is all related to the point of inflection. You see. Now, what we know is the x value of the point of inflection is here. This is the x value of the point of inflection, right? Now, this x value of the point of inflection, what you know is one side that's smiling is a side that's concaved up. One side that's frowning is a side that's concaved down. Now, with that being said, right, if they're asking us where is the graph concaved up, give a reason for your answer. Well, this question, I mean, like the side that's concaved up, right? So remember the x value here of the point of inflection is where x is equal to -1. So towards the right of -1, that's where it's concaved upwards. So we can say here x is bigger than -1, right? X is bigger than -1. That's where it is concaved upwards. So with that being said, they want us to give a reason for our answer. So to give a reason for your answer, right? I mean, like it's a 2-mark question, so you really don't want to like overthink it. You really don't want to overthink it. So the easiest thing you can always say is you can always just say the second derivative, right, is concaved up is no. Hold on. What you can safely say is if you look at your graph here, this is where -1 is. This is where -1 is. You see. Now what you know is towards the right of -1, your graph here has positive y values. So as long as your graph here has positive y values above -1, that's the graph that's concave up. And then here, this is the graph that's concave downwards. So the easiest way to put it is you can safely say that the graph is concave up where the second derivative is above the x-axis. You see, so you can say here f is but then let's use an answer that's like very easy to remember, really, because when we write it out like that, it makes it seem a bit somehow. But I guess you can just get used to putting things like that. You see, the graph, because you don't want to like find yourself wanting to manufacture answers. Just write what you know they take. So you can say the graph of f is concaved up is concaved up, where the second derivative has positive y values. You see, so this is something you can remember over time, you see, because remember, the stuff that you will find from time to time, don't underestimate those things, you see, because you'll just be able to just write those kinds of answers whenever you find similar questions. 8.4 says, show that this is P, this is Q, this is R. Show all calculations for 5 marks. So this is not very difficult, fortunately, because we're going to be starting from what you call from the bottom, and then we're going to work our way up, or like technically, because so far, fortunately, remember we wrote down all these things. You saw when I was writing them down. This is our first derivative, this is our second derivative. What we fortunately know about our second derivative is that this is like 6x plus 6. So what that means is this is like 6p and this is like 2q. So what we know is that 6 is equal to the 6p there, because that's the gradient, right? So here it basically means if you divide by 6 here, divide by 6, p is a 1, logically. So with q, what you already know is that the 2q part is represented by the 6 there. So here you'll be able to just divide by 2, divide by 2, q is equal to 3. Now for the r, right, I mean, you can see for yourself. The fortunate thing is what we already know is that you see here for the r, all we need is we have p, we have q already, and we will be looking for r. So technically all we will need is basically, if you think of it nicely, all you will need is more or less almost like a coordinate that the graph passes through, which is where this comes in. Okay, not necessarily. Okay, I guess this may not be very accurate because it's just an x value of the turning point. But it's very useful because as long as you have this x value of this turning point, right, you can actually make use of your second derivative to get r. The reason is, remember, your second derivative is a gradient equation. So this gradient equation, fortunately, what we do know about our gradient equation here is that, remember we mentioned that one of the turning points is where x is a 1. You see, one of the turning points is where x is a 1, of which at this position, the gradient, we can just say here, the first derivative is equal to 0, where x is equal to 1. So because we know that, what we can do is our first derivative, we can make it equal to 0, and we know our x value is going to be equal to 1. So this is like squared plus 2q, this is a 1 plus r. And then what now? Well, we have p and q, right? So it's 3, p is like a 1, 1 times 1 is just 1, q is like a 3, so it's like 3 times 1 is just 3, r is what we're looking for, this is a 0. So here you're going to have 3 times 3 plus 6 is a 9, and then when you move it to the other side, it becomes a minus 9. You see, that's the way we like it. So since that's the way we like it, we have gotten all our answers. I mean, like, it's all good, it's all nice and dandy. So let's move on to 8.5. It says 3 marks, hence or otherwise determine t. T is the other turning point. So this is really not a difficult thing because in our second derivative, we can just get our values of x. One of them will be a 1, the other one will be whatever t is. So let's do that. So let's see. Let's see here. Let's see. Now let's see here. Let me see here. What do we need to do? What do we need to do? What do we need to do? Okay, so hence otherwise determine value of t. So I need to paste this thing, right? So we got, I'm not putting the full equation here. So it is 3. What is P? P is like what? P was a 1. So this is, Q was a 9. So this is like 18. Right? This is like 18. And then this is X plus, what is R? R is, hooey. It's like negative 9. That's what R is. It's negative 9. And then this is like this. And then now what? Yeah, so if you're going to solve for X here, right, you can just use the quadratic formula for solving for X. So X is going to be equal to negative B plus minus B squared minus 4AC. So here we're trying to get the two X values that will result in our gradient being a 0. So, oh wait, Q is what? Q is a 3, bro. Come on. So this is gonna be a 6. Yeah, ne? We had made a mistake. So our B value here is just a 6. But we could actually, yeah, let's just do it. Here you can take out a 3 as a common factor, but I always just use the quadratic formula because I'm like, quadratic formula gang. So 6 squared minus 4A is a 3, C is a negative 9. And then what? A here is like a 3. And then what? In the calculator, we're getting here, what are we getting? X is equal to 1 or X is equal to negative 3. Therefore, T is negative 3 because the 1 is already accounted for. So the other one definitely has to be the value of T. So, yeah, because you have to choose which one is T. 5 marks says, for each values of X will this expression be bigger or equal to 0? So the fortunate thing about this statement is that we can easily just finesse it nicely, very, very nicely, because this is where your knowledge of calculus comes into play. So if you've gone through the playlist or the playlists and you've gone through, the courses and all that, this is the kind of equation that you would be able to work out, almost with your eyes closed type of thing. Okay, you need your eyes open so you can see what you're answering. But what I'm trying to say is this kind of equation, right? If you see what we are dealing with here, we said that one way or the other, our graph is going to look like this. You see, copy. So if our graph looks like that, what we do know is, remember, what we see on our image here, it needs to correspond with what you may call, with, like, our graphs need to correspond with each other. So if the turning point, the only thing now is we don't necessarily know if the turning point is, okay, let's just delete this thing really, because yeah, we might just end up confusing ourselves. For now, we'll have to maybe redraw it on top of here, on top of this thing. So what we know is our turning point, we have somewhere at T, right, which is like -3. So we have a turning point somewhere here. And then the other turning point is at +1. So it's like somewhere here. You see? So because we know that there is 1 over here, -1 over here, and then there is -3 over here. You are going to be glad that you bumped into this ad, because we are hosting an in-person math grade 12 workshop. So the idea is there's going to be 2 workshops, one in Bryanston and one in Pretoria North. The one in Bryanston is going to take place on the 18th of October until the 19th of October. The one in Pretoria North is going to take place on the 20th of October until the 21st of October. If you want to follow the proceedings online via Zoom, that will only cost you $3.99. The full details for that are linked in the description below. The main idea with the workshop is you will be able to ask very detailed questions with regarding anything metric related, actually. Applying for university, upgrading, taking a gap year, math questions, very specific, very detailed math questions. And the good news is, as long as you sign up for the workshop, you will also have access to the full online courses, meaning prior to the workshop, you will be able to go through the online courses so that on the day of the workshop, you are able to ask very detailed questions. So if you do opt to join in online, that will be from the 18th to the 19th, meaning you will be following along the proceedings that will be taking place at the Bryanston branch. The good news is, if you do sign up for the Pretoria in-person workshop on the 18th and the 19th of October, you will also be able to follow the Bryanston proceedings online via Zoom, meaning you'll be able to ask questions, I'll be able to see them directly, we'll be able to chat, we'll be able to gel. It is one of those things you definitely do not want to miss. Seats are super limited, so you can hop onto our website and check if there's still space available. So we said it's a smiling parabola, and what we know is the point of inflection is somewhere at -1. So without overcomplicating things, right, what we need to keep in mind is, for us to properly answer a question like this, we may need to at least be able to visualize what our graph looks like. When I say we may need to be able to visualize what our graph looks like, I just mean exactly that. We need to be able to visualize what our graph looks like. So we may need to go as far as drawing, the graph itself. For the sake of explaining, that's what may work better. So what I'm trying to say is our turning point is at 1 and -3, right? So let's see what we would get if we throw 1 and -3 in our original equation. So in our original equation, well, technically our original equation is f of x is equal to like x cubed. P here is, what is the p value? Remember, q here is like a 3, right? You get it? Q is a 3. Yeah, q is a 3. So this is like what? 3x squared. And then r is like a -9. -9x, and then -27. So with all that being said, copy. Or let's cut it rather. Cut, because we need to take it down here. So all that being said, right? Let's see where the y values would be. Now you may be asking, do we really need the y values? Because yeah, well, in this situation, it looks like we kind of do. But you'll see the method in madness now, just as after I have gotten the coordinates now. So if you throw +1 wherever x is, right, let's see what you're gonna get. 1, if you cube it, let's see here. If you cube it, it's like cubed here plus 3, and then 1 if you square it there, -9, and get 1 here, -27. So this is going to give you -32, right? And then the other one, what's the other x value? -3, right? So you're going to put -3 over here, -3 over there, -3 over there. So that one is going to be a 0. So you see that the -3 is important, because it gives us an idea of what kind of a graph we're looking at. So our graph, since it's a positive cubic function, it goes up and then down afterwards. So the way our graph is going to look, because because the x value is a -3 and the y value is 0, it means this graph goes up, down. Go away. It means it goes up and then down, right? And then up and then down. And then somewhere here at negative somewhere at -1, right, it's gonna start making its comeback until somewhere at 32, at -32, it's gonna turn and it's gonna go up like that. So down here it's gonna go down like that. So this is what our cubic function looks like, from a visual perspective. Now, with that being said, if we now extend our straight line here, it's going to help us answer our question better. So our straight line goes like this all the way down, but let's try and make it go all the way down until, just like this is fine, because what actually matters is like positive y values and all that. So what we know is this is representing y values of f, and then this is representing y values of, the second derivative. So the question is literally asking you, if you're going to be multiplying these two things together, where will you have a positive y value or a y value that is equal to 0? Where are you going to get, the question is basically asking, if you're going to multiply these two together, where will you have the expression being a positive number or a number that is equal to 0? So the only way you can have this thing here produce a positive number is if you are multiplying a positive and a positive, or if you're multiplying a negative with a negative. Now, the only way it can be 0 is if at least one of them is a 0. But that's the list of your worries. If you can just answer the two questions we have proposed here, you'll be good to go. So what I mean by that is the following. Right? This is what I mean by that. All you want to do now is you want to be comparing the y values of these graphs, basically. That's all you have to do. You just need to be comparing the y values of your graphs. So comparing the y values of your graphs, what you already know is, you see from this point here, this has positive y values. It has positive y values, and it's going to have positive y values all the way to infinity, right? But the only place where this other graph starts to have positive y values is from this x value here. From this specific x value going onwards to positive infinity, that's the only place where it's going to start having positive y values. So we are looking for a scenario where the one graph has positive y values while the other one is also having positive y values. Now that is only happening from this specific x value going all the way to infinity. So we need to find this x value, and this x value is our x-intercept. So one of the x-intercepts of our parabolas, of our cubic functions, you see we need to find it. Now finding this x-intercept, you can be thinking to yourself, wow, whew, so much work, because you've probably be thinking to yourself like, dude, why does it seem like we're doing so much work? Like why does it seem like we're doing so much work? Now, I understand the idea behind what you may be thinking now, but the thing is, what we're doing now is somewhat unavoidable. We need to find this x value. Now you may be asking yourself, what's the easiest way to find the x-intercept of our cubic function there? Now, one or the other, right? The one thing I can safely say is there isn't necessarily like a blunt, straightforward way to find the x-intercept of your graph there. You just have to do exactly what you would always do for you to find the x-intercept of your graph, you see. So what you can do to get the x-intercept of your graph, fortunately, what you know is that you just need to work with what you may call, you just need to factorize your equation. Now you can factorize your equation you can use long division, So what I'm trying to say is, if you're going to factorize the equation for you to get the x-intercept here, remember what you're trying to actually do, right? All you're basically doing here is you're making the equation equal to 0, right? So what you know is, this is like what? X cubed plus 3x squared, and then the other one here is like negative 9x, and then from there it's like what? Negative 9x and then negative 27. Okay, so in this situation, right, we know that one of the x-intercepts is this one, negative 3. So what we know is, if you're going to use long division to factorize an expression, this is what you do. The negative 3, we're going to put it in something like this, and then the coefficients of all these terms, right? There's a 1 here, you're going to put a 1, 3 there, negative 9 there, negative 27 there. And then you're going to leave a line open, right? So you leave a line open, and then with this line open, now this is what you do. This is what you need to do. So the first thing is you drop the 1, right? You're going to put it over there, and then you start. Negative 3 times 1 can give you -3. You put your answer over here. Now the thing is, what you do is these numbers you have to add. 3 plus -3, that's a 0. And then you start again. -3 times a 0, you put your answer here, it's a 0. -9 plus a 0, that's -9. -3 times -9, positive 27. So -27 plus 27, that's going to give you a 0. You see? So the idea is, now that you're looking at it, the question here is going to look as follows. You see? So you're gonna have here y. No. You're gonna have, since this is a negative 3, right? You're gonna have x plus 3 here as one of the factors, and then here you're gonna have x. There's a 0 in the middle, right? So it's x squared here, then there's a 0, then there's a -9. This is just a difference of 2 squares. So it's gonna be x plus 3, x minus 3, and then x plus 3, like that. So with this being said, right, with this being said, you want to keep in mind the following. You want to keep in mind the following. You want to keep in mind that obviously this is equal to 0, right? So already we know that the -3, because there's also a turning point there, it's coming from these two brackets. So the x minus 3 there is telling us that this number here is a plus 3. Okay, so now that we know that that number is a plus 3, we can answer our question nicely, because remember we said we want cases where both graphs are having positive y values. Now they are both having positive y values where our x values are, you can say here x has to be bigger or equal to positive. The reason why we're saying bigger or equal to is because you see here, this is asking where is this above or equal to 0. So this to be above or equal to 0, both have to be a plus, or both have to be negative. So let's look for cases where they are both having negative y values. So fortunately, that's happening starting from -1 over here, right? Going all the way to -infinity, because from -1 going all the way to -infinity, this is having negative y values. And then during all this time here, where these are negative y values, you also then have this is a -1, right? So you have -1 over here, and then this goes like this, going all down to -infinity, like that. That's like negative. So x here, you can say, oh, x is smaller or equal to -1. That's like one way to also deal with this kind of equation. So let us move on to question number 9. Question number 9. Okay, so question number 9 looks, yeah, looks quite interesting. But let's see. It says a soldier, or the soldier, which is standing here, shoots at a fixed target, right, which is TQ, on the crest, which is the highest point of the hill. Then it says the height of the hill is represented by the equation x squared plus 4x minus 3. So it's a parabola. So this is the height of the hill. So the hill obviously ends somewhere there, and then the tower begins, or whatever this TQ is. It says it's a target. Then it says here, your graph is only being shown from where x is a +1 until where x is a 3. So already we know that this x value is a 1, this x value is a 3. So this is like 1 here, 3 there. So the big idea is, with that being said, right, what does it say? P is a point on the hill. So P is a point on the hill. Yes, it means that if this dotted line is talking about the path that the guy is going to shoot, then it means that that line, that path, if you're going to draw a line, that line would be a tangent to P. and would be a point, would be a tangent at P, and it would be a tangent to the hill. Is it rather than an expression for the gradient of the hill in terms of x? So that's fine, because remember, gradient refers to first derivative. So they're asking for the equation of the first derivative, and we can easily give them the equation of the first derivative. The equation of the first derivative can start from here. H of x is going to be equal to negative 2x squared. No, negative 2x plus the 4. See? And then, I mean, the negative 3 definitely kind of just goes away. So let's see what we got here. Take all this, let me copy it. And then this is what we have for question 9.1. So we can just paste that over there. Paste it, make it go bigger. And then it says here, what is the smallest angle theta that the soldier can aim to shoot the target? You are going to be glad that you bumped into this ad, because we are hosting an in-person math grade 12 workshop. So the idea is there's going to be 2 workshops, one in Bryanston and one in Pretoria North. The one in Bryanston is going to take place on the 18th of October until the 19th of October. The one in Pretoria North is going to take place on the 20th of October until the 21st of October. If you want to follow the proceedings online via Zoom, that will only cost you $3.99. The full details for that are linked in the description below. The main idea with the workshop is you will be able to ask very detailed questions with regarding anything metric related, actually. Applying for university, upgrading, taking a gap year, math questions, very specific, very detailed math questions. And the good news is, as long as you sign up for the workshop, you will also have access to the full online courses, meaning prior to the workshop, you will be able to go through the online courses so that on the day of the workshop, you are able to ask very detailed questions. So if you do opt to join in online, that will be from the 18th to the 19th, meaning you will be following along the proceedings that will be taking place at the Bryanston branch. The good news is, if you do sign up for the Pretoria in-person workshop on the 18th and the 19th of October, you will also be able to follow the Bryanston proceedings online via Zoom, meaning you'll be able to ask questions, I'll be able to see them directly, we'll be able to chat, we'll be able to gel. It is one of those things you definitely do not want to miss. Seats are super limited, so you can hop onto our website and check if there's still space available. So when they say smallest angle, well, technically this is the smallest angle the way it is currently, because if it's going to shoot the target enemy higher, it's going to be increasing this value. So the way it is now is technically the largest angle. So let's see what this mark allocation is. Out of 6, yo. So this is what I'm thinking of. So if we're going to get the angle here, we can think of Pythagoras theorem. We can just think of this right angle triangle. We can get the x value of P, and then we can if we have the x value of P, we have this distance. If we have the y value of P, we have this distance. Then we can use tan to get theta. Excuse me. So yeah, that's where things get a bit interesting, because specifically at point P, we don't know what the point is. We actually don't have any kind of information for us to be able to for us to be able to get information about P. The only thing we do have is this x-intercept and this x-intercept. The value of P, but I don't even know why I'm thinking too much about that. If we're going to be talking about where this tangent meets the straight line, we don't have any information about the straight line also. So it obviously definitely does make things a bit tricky for us, you see. But we have to, this is where you have to almost like think outside the box, because if you don't think outside the box, yeah, it's not gonna be good. It's really not gonna be good. So let's see here, equation of the parabola. Let's see here, what do we have? Yo. This is interesting. So what we do have though, we can think of the equation of the what you may call. We can think of the equation of the tangent. The thing about the equation of the tangent is that the gradient of the tangent would be the gradient of the curve at the point where they meet, you see. So yeah, this is just a bit crazy because if we get the equation of the straight line, can we get the equation of the straight line? Because I mean, like the y-intercept is a 0 anyway, so let's just see what happens if we try and get the equation of the straight line. So it's a tangent to a curve. So our tangent, what's the equation of our tangent? That's h. H is equal to going on and on and on. So h of x, right, is equal to negative x squared plus 4x. Negative x squared plus 4x plus 4x minus 3, right? Minus 3. Okay, there we go. If you differentiate it twice, you're gonna get whoa, just do it properly. Okay, so let's see what we're gonna get here. Negative 2x, and then this differentiated is just gonna be a 4. Okay, that makes our life a bit you know, a bit doable. Okay, so with this one now, what do we know? A tangent. So specifically at this point, right, we know that this equation the equation that we have now gives us the gradient at any point. But what we do know is that this gradient at any point is what you may call, what am I trying to say now? Bro, what are you saying? What are you saying? What are you saying? What are you saying? Yeah, so this is obviously not a straightforward question. It's quite non-straightforward. So if we're going to psychoanalyze this question, right, the one thing we can already think to ourselves is, you know what, if we're really going to do this, one thing we know is this specific x value here and that particular y value, it is basically related to the distance between here and there, and the distance between here and there, that's y. So what we already know is that tan theta is opposite over hypotenuse. Now the big idea here is our coordinate of what you may call this coordinate here specifically, the x value and the y value, we know that we can get it from our equation of our parabola. You see, literally the coordinate of p, whatever x value it is, the y value is going to be negative x squared plus 4x negative 3. You see, because remember p is an x value and a corresponding y. So what we're saying is if you throw this x value into the equation, this is what the y value is going to come out as. That's the logic behind what we're saying. So what we know is the y value at p is basically just negative x squared plus 4x minus 3, right? The x value is just x. You see, because we're taking this y value here, which is what we just wrote out, this x value here, which is just what we wrote out. And we know this is what tan theta is equal to, you see. So if you're gonna solve for, here they're saying what is the smallest value of theta that the soldier can aim. So here, since we're solving for theta, right, we can just carry on and simplify. Maybe you're gonna have this over x, 4x over x, then minus 3 over x. Here you're gonna have this canceling that, it's gonna give you negative x. This canceling that, it's gonna give you 4. Then here it's like negative 3x of negative 1, then this is tan theta. So at this point in time, you may be asking, but what now? You know, what's the next step? What do you do to deal with this whole element of having x there? So what we do know is that we may be thinking to ourselves, okay, fine, with whatever parabola we're dealing with, I mean, with this dotted straight line, right? With this dotted straight line, the equation of that straight line would be y is equal to mx plus c. But the thing is, our c value is a 0 because the y-intercept of that line is clearly a 0, as you can see here. So our equation of our parabola is just y is equal to mx. So the thing is, our value of m, it is basically just the what you may call, our value of m is basically the gradient of what is this? It's basically the gradient of the gradient at this specific point here, and we can get this gradient at this specific point because, I mean, like, if you think of it, if we get the gradient of this line, we can easily get this angle, because remember, there's a formula that says tan theta is equal to m. You know, we can get the angle of inclination there if we have the gradient of this line. Getting the gradient of that line, we know it's just, you can use your first, did I just put here, why is this thing doing? This is your first derivative, bruh. The first derivative is the gradient equation. So what we know is technically y is equal to, the gradient is negative 2x plus 4, right? Negative 2x plus 4. Negative 2x is the gradient. Yeah, that's the equation that's going to give us the gradient. So what we do know is, since tan theta is equal to m, and we know that m is negative 2x plus 4 because that's the gradient, what we know is we can make tan theta equal to each other and then solve for x, and then throw the x into the equation and then solve for theta. So here we can say, therefore, this here, negative x plus 4 minus 3 with a negative 1 there, x power of negative 1, this is equal to negative 2x plus 4. And then we're gonna have, if you solve for x here, how is this gonna come out now? Well, we can revert back to what we had over here because it looks like it would be easier to work out. Because technically speaking, the way it is now, yeah, it's not gonna help us. It's not gonna help us. We'd need to have the whole thing, this squared, and with our x back there. And then, no, let's just do it systematically so we don't lose anyone. So from here, if you're gonna solve for x, right, what we know is, because we're gonna have a new LCD, the LCD here is just x. Okay, so from here, we know that we need to multiply each of these individual terms by x. We're gonna get here, let's see, so this we're gonna multiply by x over x, this we're gonna multiply by x over x, and then on the other side we're also going to multiply everything here by x over x, negative 2x plus 4. Okay, so let's see what we're gonna end up with. So from here we definitely want to be a bit cautious, but let's see, this is gonna give us negative, what's the thing now, negative x squared plus 4x minus 3, right, the whole thing over x. And then this is equal to, if you multiply inside, you're gonna get negative 2x squared plus 4x, right, the whole thing over x. But obviously you want to get rid of the denominator, so each side you're going to multiply by x, and then you're ending up with negative x squared plus 4x minus 3. Let's take this to the other side. You're going to have plus 2x squared minus 4x equal to 0. So what we can already see is that this cancels that. These are like terms. Negative 1 plus 2 is going to give you a 1, and this is like minus 3 equal to 0. Okay, solving for x, what do we have here? I think we might as well carry on from this way up there, so we don't run out of space. So carrying on from here, we can see that, let me use a color that pops. X squared is going to be equal to positive 3. Put everything under square root. You're going to get plus or minus 3 as your answer for x. So obviously, if you're going to get plus or minus 3, I mean, since we're working out an angle, you obviously need to use the positive number. I mean, plus or minus square root of 3. So using the positive number, what we already know is that, remember, what we said is that wherever theta is, it is a place where you can, or rather, if you look at it again, theta here is an angle of inclination. And we know that there is a formula for the angle of inclination. M is equal to tan theta. So our M in this case, what do we know? What do we know? We don't know whatever M is, but we did say, no. We're working this out simultaneously. So we got X here, we can now throw it into one of our other equations, which is this one, you see. So here what we know is tan theta is equal to -2 square root of 3, and then plus 4. So the reason why we're choosing a positive square root of 3 is because, I mean, like, one way or the other, what we do know is that we are working on the positive side of our x-axis. So let's see here what we're going to get. This is going to give us, in the calculator, all this is going to give us 0.54 if you round off to 2 decimal places. And then from here, we can just work out theta by saying shift 10, 0.54. Let's see what that is in the calculator. Okay, this is giving us 28.19. There we go. There we go. Okay, yeah, so this is the angle of theta. Let us move on to the next question. Question 10 says, a survey is conducted among 220 learners, right? 220 students at a university. The results are shown below. You have 40 learners or 40 students doing physics, 117 doing math, 90 doing commercial science. Then it says 21 students study physics and commercial science. And then it says 53 students study math and commercial science. 12 study physics and math. 50 do not study physics, math, or commercial science, meaning they don't do any. X students study physics, math, and commercial science. So when you're going to be reading this data, you're going to read it again while putting it into your Venn diagram. Because the thing is, when they say 40 students do physics, it just means in this whole circle, all the numbers should add up to 40. 117 students do maths. In this math circle, all these portions need to add up to 117. 9 students do commercial maths. That's I'm putting the number in brackets to say everything in here should add up to like 90. What we do know now is when they now say 21 students study physics and commercial, what it means is here in these two blocks here, these two add up to 21. So if this plus this is 21, it means that this is 21 minus x. Because everything is 21, right? So if you remove x, you're going to get what you're going to put there. The next one says 53 do maths and commercial science. So where commercial sciences and maths meet. Yeah, so it says here 53 students study maths and commercial sciences. So where commercial sciences and maths meet, we know that these two should add up to like 53, right? So if this is x and the whole thing should add up to 53, it means that this here is technically 53 minus x. And then the next thing that they said is 12 students study physics and maths. So it means where maths and physics meet, which is here, those two should add up to 12. You see, so it's this here, meaning this is going to be 12 minus x, you see. So with all that being said, they then said here 50 students do not do anything, any of the three. So it means out here we have the number 50. And then it says here x students do all of them. So in a situation like this one, right, what you can do is you always want to solve for x first. It says here copy the Venn diagram, whatever. And then they said we should copy the Venn diagram in the answer book, then represent the information on it. So if you're going to represent whatever you're going to represent on the Venn diagram, okay, so the one thing you can do here is you can actually solve for x using what now? I feel like with all of these, I feel like I missed something. you know. 40 students only 40 students study physics, 100 and something maths, 90 commercial. 21 students study both of these, 53 both of these, 12 both of these, 50 do not study anything. And then it says X study these three altogether. Yeah. Yeah, so this is where things get a bit tricky because, okay, fine, we copied and we put the information. Then they said here, calculate the value of X, the number of students that study all three. So we have to solve for X. So the idea behind solving for X is what we know is this portion here is 40 minus this, minus this, minus that. That's what this portion is actually. But then putting that in there, I don't think it's going to help us with anything. Is it really? Yeah. I feel like I'm overthinking all this because I feel like my mind is also going a bit blank because it seems like, yeah, I mean they've given us all the information we need, but at the same time it almost doesn't feel like they've given us all the information we need. It almost seems like they've forgotten something. So that's just the vibe that I am getting from all these questions here. You see. So let's see what we can do about it. Let's see, 40 students study physics, 117 maths, 90 commercial sciences. Ha! Why am I going blank all of a sudden? Like seriously? Because 50 students study. Oh, oh no, 50 students do not study physics, mathematics, or whatever. So that's like where this 50 comes in, obviously. And then what now? 12 students study physics and maths. So physics, where physics and maths meet, that's supposed to be 12. And then 53 students study maths and commercial science. That's these two. And then 21 students study physics and commercial maths. So that's these two. Then it says 90 only. Ha! I don't know where the blonde moment is, but let's see here. If we're thinking of this space, right, specifically, then what we could be thinking of is something like 40 minus 21 minus x here, then minus the x, and then minus the 12 minus x, right? So you're going to have your 40 minus 21 plus x, right? And then minus x, minus 12, and then plus x. These go away. You're going to have negative 21 minus 12. Well, I feel like I'm overthinking this actually. But funny enough, it seems like it's unavoidable, you know? So here, 40 minus 21, that's going to give you 19. Minus 12, that's going to give you 7. So this is 7 plus x. That's what goes here. We have to do the same for this slot. We have to do the same for this slot. And then we have to make everything equal to 50. So here in this position here, it's going to be 117 minus this thing here. So it's going to be minus 12 plus x minus the x there. Minus this is going to be minus 53 and then plus x technically. And then you're going to have here, what are you going to have? These are going to cancel each other out. And then you have 117 minus 12, 117 minus the 12 there. For this section here, it is going to be 90 minus this, minus this, minus this. It's going to be 90 minus 21, then it's going to be plus x, minus the x there, minus the 53, then you're taking plus x. So here, that's what this section is going to be equal to, right? 90 minus those three. And then if you simplify it, you see this here cancels this here, then it looks like you're going to have 90 minus 21 minus 53. You're going to get a 16. So this is 16 plus x. Now the idea is, carrying on, right, you need to make sure that you add everything up, including the 50, and you make it equal to 220. So let's do that. So if you do that, you're going to have here the 7 plus x you're going to have the 21 minus 7, the 21 minus x. You're going to have the x plus the x here, plus the 12 minus x, plus the 52 plus x. Then you also have to add the 53 minus x. And then you also have to add the 16 plus x. And then that's like 1, 2, 3, 4, 5, 6, 7 things. 1, 2, 3, 4, 5, 6. Yo, I think I added everything up. 21 minus x. And then there's the x, there's the 12 minus x, there's the 52, there's the 53. Oh, I forgot the 50. You see? And the 50. Everything should be equal to 220. If we look at everything nicely, let's see what we're getting. We're getting here, let's see here, all the numbers add up to 211. And then this is minus x equal to 220. No. What am I saying here? Negative this. And then if you go over to the other side, you're gonna have x here is equal to 2 2's. No. What am I saying? Take this over to the other side, you're gonna have minus 211. X value is a 9. There you go. So let's move on. 10.2 says if a student was selected at random, calculate the probability that he or she studies only one of the courses: physics, maths, or commercial. So remember, studying only one means, let me put in red what each of these things would be. Let's see, if you're going to study, the probability of studying only one, okay, so what you do is the people that study only one, it's these people here, these only study one, it's these people here, these only study one, and it's these people here, those also only study one. So in this section is going to be 7 plus x, right, which is 7 plus 9. In the other section it would be 16 plus 9. In the other section it would be 52 plus 9. And then out of a total of 220 people. So here we have 9 plus 7 plus 16 plus 9 plus 52 plus 9. That's like 102 over 220. So that is a, if you simplify it, 220, it's going to give you 51 over 110. There you go. That's the probability of whatever they're talking about. The next one, we can move on to the next question. Question 11 says the following. A coach of a first hockey team wants to take a photo of his team, the 11 players on his team. The 11 players in his team were the captain and vice captain and other 5 players are in grade 12 and the other 4 are in grade 11. So it's 5 plus 4, that's 9. 9 plus the vice captain and the captain gives 11. This is the 11 players are placed at random in a row to take a photo. In how many different ways can the coach move 11 players for the first photo if the captain should not sit on one of the ends? So if the captain should not sit on one of the ends, what you do is you have to look at it like this. There's 9 slots in the middle here, and then there's a slot here, and there's a slot there. So the idea is, what you need to look at it as 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So what you need to do for yourself is you need to think to yourself, when people are being seated, the number of people that can possibly sit here, it's 1 out of 10 people, right? The moment one person sits here, you have to think to yourself, the number of people that can sit here, it is going to be, once one person is placed here, right? Remember we said only 1 out of 10 people can sit because the captain cannot. So in this position also, once one person is set here we have to put a person. and we can only sit 1 out of 9 people. So once one person is here and one person is here, in these slots in the middle here, now remember we have a total of 9 people left. So in these slots, we can say in this position, 1 out of 9 people, and then once one person is sitting there, there's 8 slots left, going on and on and on until there's only 1 slot left here. So for the seats in the middle, these people can sit in 9 factorial ways. Then at the end, we said there's 1 out of 9 options for the end, there's 1 out of 10 options for the beginning. So this is going to be your number of arrangements based on what they've told us. So times 9 shift factorial times 9. That's like 32 million. 32,659,200. You see. The next one says 6 marks. Yo. For the second photo, the captain and vice captain must sit on either end of the 5th and 6th chair. What is the probability that a grade 12 player will not sit on the first chair and a grade 11 learner? Whoa, this question is just so crazy. What is the probability that a grade 12 player will not? No, what is the probability that a grade 12 learner will sit on the first chair and a grade 11 player on the last chair? So in this situation, you have to remember that also 9 slots: 1, 2, 3, 4, 5, 6, 7, 8, 9. So the big idea here is what we do know, right, is they said for the second photo, the captain and vice captain must sit in any order on the 5th or 6th chair. So 1, 2, 3, 4, 5. 5 and 6. So these guys have to be here. So let's sort those out first. So in this seat, there's 1 out of 2 people that can sit there, either the vice captain or the captain. And then in this seat, there's 1 out of 2. If one person sits here, only one person can then sit over here. But the thing is, yeah, this is the only arrangement for these middle seats here. Because you could think to yourself, there's a scenario where the captain is here, the vice captain is here. There's a scenario where the vice captain is here, the captain is there. So for this specific slot, this is the only kind of arrangement you can have. Then they said we're going to then need to work out a probability of something. So let's not worry about the probability part of things. Let's worry more about how they said a grade 12 learner has to sit in the first chair. So a grade 12 learner sitting in the first chair, how many grade 12 learners do we have? We have a total of 5 grade 12 learners. So in this first chair, there's 1 out of 5 options. And then once you put a person there, they said grade 11 has to sit in the last chair. So in the grade 11 slot here, you have to remember that there's 4 people in total. So there's 1 out of 4 options for this last chair. So once you have set a person here, a person there, a person here, and a person there, that's 4 people in total. So out of 11, the number of seats that, the number of people that are not seated right once 4 have set is just 7. So of those 7, what you have to remember is that here you can sit 1 of 7 people. Once one sits here, there's 6 options, then there's 5, and there's 4, and then there is let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Bro, 10, 11, bruh. Supposed to be 10. It's not supposed to be 11 seats. 10, 11. Wow. So when I was talking about the last slot, I was supposed to be talking about this one. Yeah. So that when we are going to sit the rest of the people, there's 7, 6, 5, 4, 3, 2, and then 1 option there. Because we said position 5 and 6, right? It's vice captain and captain. So we put it like that. In the first position, grade 12 learner. In the last position, grade 11 learner. And then the rest can just sit anywhere. So there will be 7 options here: 6, 5, 4, 3, 2, going on and on and on. And the idea now is for you to see how many arrangements these are, you just multiply all these numbers together. Just multiply them together. And then we're going to put them over the total number of possibilities without any restrictions. The number of arrangements would just be 11 factorial because there are 11 places. That's if there are no restrictions. So for this probability equation, we have to say these number of arrangements over the 11 factorial. So with these numbers are multiplying, right? The 5, the 7, and all that. 5 times 7 times 6 times 5 times 2 times 1 times 4 times 3 times 2 times 1, right? And then times 4. This is giving you 201,600. 201,600. So this over 11 factorial, let's see, divided by 11, shift factorial. That's going to give you 1 over 198. 1 over 198. There's your probability of what they talked about for 6 marks. And that's that for this paper. This paper was not so bad. But anyways, as you can see, in terms of, as you have seen during this video, we definitely do have a workshop coming up. It is on the 18th and the 19th of October, 2022. Well, obviously, I mean, if this is another year, I think this may actually just be a yearly thing, because I mean, COVID is behind us, right? And then, starting at like 8 up until like 3:30. And obviously, there's 2 ways to attend. The first option is in person. And the other option is like online. So obviously in person, you can imagine everything is just going to be live anyways. So online, it just means you're going to be following the proceedings via Zoom. But then in person, that's like R999. Online, that's like R499 as of this recording. So yeah, depending on what year it is, I mean, like, these things may change. However, with what I've just referred to now, let me actually even double check. Should I double check? I think it's like 399 actually. You can actually just double check by going on clicking the link in the description, because I'm actually thinking it's 4. Is it 4? Let us double check by going straight to where we're supposed to go to. You see, so with what we're supposed to do, or with what I've referred to now, right? Let's see here. We need to just refresh this page. So if we're refreshing this page, what is it showing us? Yeah, it is showing us the first option, the second option. Oh, it is 3. Oops. Well, I guess you're in luck then. So yeah, the link to that is in the description. So you can always just go there and find more information. If you have more questions or if you have any queries, then you can always just hit me up whichever way that you can. Yeah, on my side, I'll catch you in the next video. You are going to be glad that you bumped into this ad, because we are hosting an in-person math grade 12 workshop. So the idea is there's going to be 2 workshops, one in Bryanston and one in Pretoria North. The one in Bryanston is going to take place on the 18th of October until the 19th of October. The one in Pretoria North is going to take place on the 20th of October until the 21st of October. If you want to follow the proceedings online via Zoom, that will only cost you $399. The full details for that are linked in the description below. The main idea with the workshop is you will be able to ask very detailed questions with regarding anything metric related, actually. Applying for university, upgrading, taking a gap year, math questions, very specific, very detailed math questions. And the good news is, as long as you sign up for the workshop, you will also have access to the full online courses, meaning prior to the workshop, you will be able to go through the online courses so that on the day of the workshop, you are able to ask very detailed questions. So if you do opt to join in online, that will be from the 18th to the 19th, meaning you will be following along the proceedings that will be taking place at the Bryanston branch. The good news is, if you do sign up for the Pretoria in-person workshop on the 18th and the 19th of October, you will also be able to follow the Bryanston proceedings online via Zoom, meaning you'll be able to ask questions. I'll be able to see them directly. We'll be able to chat. We'll be able to gel. It is one of those things you definitely do not want to miss. Seats are super limited, so you can hop onto our website and check if there's still space available.